Good morning. I'm Kaushal Chari, Dean of UWM's Lubar College of Business. I'm so delighted to welcome you to today's Artificial Intelligence and Analytics Symposium. The Lubar College is very proud to offer this webinar to the public, sharing the expertise of top academics and executives and our own outstanding faculty on the latest in both research and practice in AI and analytics. This webinar is sponsored by the Lubar College's Center for Technology Innovation, which fosters a community of faculty, business leaders, and students to explore the opportunities offered by innovative technologies such as AI, machine learning, and big data. And through public programs like today's symposium and its long-standing workshop series, the center seeks to promote discussions that lead to solutions in the information technology environment. I would like to express our appreciation to today's symposium's sponsor, Church Mutual Insurance, for making this event widely available to our audience. Thanks for the folks at Church Mutual. I'm now happy to turn the program over to Dr. Scott Shanke, Director of the Center for Technology Innovation at the Lubar College of Business. Scott is doing some very interesting research that seeks to identify and quantify effective approaches to the design and implementation of the entities that represent firms and brands in customer interactions, including AI-enabled conversational agents and digital brand personalities. Scott, thank you for organizing today's symposium, and we really look forward to all the insights into disruptive innovation from our experts. So Scott, over to you.
Thank you very much, Kaushal. It's a great pleasure to bring to you this year's AI Analytics Symposium centered on the theme of disruptive innovation. In the last 6 months, we've seen an emergence of different technologies which could drastically change the trajectory of business and the world we live in. We have carefully selected speakers for this symposium to highlight how these disruptive AI technologies were created, what impacts they have on society, and their ethical implications. To set the ground rules for today, what we want to do is, so we'll have the chat feature in this webinar disabled. If you're interested in asking any of the speakers a question, feel free to enter this in the Q&A section, and I'll read these to the speaker at the end. So to begin today, so we'll have different sessions, each on every hour. So to begin, we'll be having Maribeth Achterberg talk about the ethics in AI. At 10, there will be a little bit of a break between her talk and Rajesh Gupta's talk at 10 o'clock on embedded intelligence. Then we'll go into some interesting talk on the disruptive economics of AI by Dr. Avi Goldfarb. And then finally, we'll end on a panel discussion with some local innovators talking about their experiences being innovative in Southeast Wisconsin. So to begin, I would like to introduce Maribeth Achterberg. Maribeth is the Vice President of Solution Delivery and IT Executive Leadership Team member at Molson Coors. Currently, she leads an organization of 200 employees with a wide range of IT and solution delivery backgrounds. In addition to her accomplishments at Molson Coors, she also is a leader in our community, serving as a board member for Women in Technology Wisconsin, as well as several other organizations that promote women in technology and leadership. Thank you very much, Maribeth.
All right, well, good morning, everybody. I'm going to share my screen. And we'll get started. All right. Fantastic. Well, thank you so much for having me this morning to speak to you on the topic of ethics in artificial intelligence uses in society. And I'm impressed and encouraged with the intelligence and energy around this topic of artificial intelligence and analytics. I think the curiosity and energy on this topic is fuel for innovation and better outcomes to education, commerce, and maybe even governance issues we face today and in the future. And it's my pleasure to speak with you today. I'll go back past that. It's my pleasure to speak to you today on the topic of ethics and artificial intelligence. AI has the potential to revolutionize the way we live, work, and interact. From autonomous vehicles to healthcare to education, AI is gradually finding its place in almost every aspect of our lives. But with this increased adoption of AI, we must also consider the ethical implications associated with it. And the commercialization of AI has indeed hit critical levels, and it's crucial to ensure its ethical use to safeguard society. All stakeholders in the development, deployment, and use of AI technology should recognize their obligation in this regard, including academia, industry players, and governments. AI is not a new concept. Thomas Davenport and Gene Harris published an influential book in the early 80s called Competing on Analytics that laid out the analytics maturity curve. And in it, they observed that there were some companies that were doing more with their data than just running reports and looking backward in time. Most companies were doing that with aggregated data and then drilling into more granular data to gain insights about what happened in a diagnostic review. And then the next level of the analytics maturity continuum was predictive analytics with tools that forecast sales based on historical data or whether a customer would stop buying a company's products. And then the next level of maturity was prescriptive analytics. So continuing to use the customer churn example, prescriptive analytics would predict this action and send a countermeasure, such as a coupon to incent them to stay with a product and compel them to purchase. But what we all really wanted as people who were in this field, and I was also in the 80s, was generative analytics. And how do we take what is, understand it, and drive to something that does not yet exist? It's not predictive, it's not prescriptive, it's generating something new. And we've been at this for a while now, making slow progress until recently. This proliferation of cloud computing and the architectural impact of rapid sharing and open source research sites. We have entered a new era, and it's exciting. But I'm going to call for a bit of caution and a pause as we imagine the impacts of the power of recently introduced generative large language models and their power. This is a disruptive moment in human history, much like if you think all the way back to the steam engine and then the personal computer, or more recently, streaming content. And as an example, I want to be able to highlight social media platforms and the disruptive impact this technology has and continues to have on a generation of humans, maybe even 2 generations. Social networking became available in the late 1980s. I used America Online myself to stay connected in the evenings when my daughter was young. This early social media platform wasn't mobile enabled. It was literally accessible by unplugging your phone line and connecting your computer to the dial-up. And I realize maybe only 25% of the audience has experienced this or even understands what I'm saying right now. But it was a long way to the current social media platforms such as Snapchat, TikTok, Facebook, Twitter, etc. we use today, and the mobile-enabled capabilities that find their ways into children's hands, literally. I think we've all been in restaurants seeing toddlers swiping or on an iPad or looking at a game to manage their attention. Technology and algorithms that help to hone content to what the viewer wants to see or the sender wants them to see. and some of them too young to realize that there are other points of view, experiences, and facts that exist, but do not surface because the content algorithms that are trained to show them exactly what they choose to consume and thereby creates a myopic worldview. And we know from history, recent and past, that myopic worldviews are dangerous territory. And finally, some 4 decades later, maybe a full generation of humans later, our Surgeon General has issued a warning about the use of social media by children. With adolescence and childhood representing a critical stage in brain development that can make young people more vulnerable to the harms of social media, the Surgeon General is issuing a call for urgent action by policymakers, technology companies, researchers, families, and young people alike to gain a better understanding of the full impact of social media use, minimizing the benefits, minimizing the harms of social media platforms, and creating a safer, healthier online environment to protect children. Let's not repeat this same pattern with this new disruptive technology of generative AI. So as we embark upon this journey, we must remember that ethics should be a guiding principle in the development and deployment of artificial intelligence. And referring to the moral and legal principles in development, deployment, and use of AI technologies. There are 5 ethical principles that must be kept in mind while building an AI system: transparency, accountability, privacy, safety, and fairness. So let's talk about transparency first. So an AI system should be transparent in its decision-making process. And the decision-making process should be open, explainable, and understood by users. For example, if AI is being used in a hiring process, the decision-making process and the algorithm used should be transparent to the job applicants. Now, in the spirit of transparency, I'm going to tell you that I use ChatGPT to assist me in the research of writing this speech. And frankly, I think that's a good use of the tool, but I want you to understand that I was AI assisted and enabled. And that's, I think, the spirit of transparency. And we need to be able to say that's important when we're using this technology. The next principle to be considered is accountability. And the developers and deployers of AI must take responsibility for the actions of AI systems under their stewardship and really realize that you're a steward of that system. In case the system is causing negative consequences, the deployers must be held accountable for the same. They must be proactive in identifying and addressing the issues that arise when the AI system is deployed. Now, harken back to my social media examples. It's imperative that industry does not seek to maximize profit over the general health and well-being of members of society, particularly young people. Social media platforms did not assess the impact of the algorithm on a developing minor's psyche, or the social responsibility should be designed in rather than racing to release without understanding the limitations or the lack of safeguards provided in the version being developed. I actually applaud the warnings by Elon Musk and Sam Altman, who, whether you agree with their life choices or not, are calling for better controls on generative AI technology because we don't have safeguards enacted. So something to think about. Frankly, I am a capitalist and I'm calling for caution. So that should give everybody pause. The third principle is privacy. AI systems collect massive amounts of data on users. It is important to ensure that AI systems only collect data necessary for its functioning, and that the data is strictly used for that purpose. AI systems should also comply with user privacy policies. AI generative models are becoming an architectural fixture in popular commercialized platforms, such as SAP, Salesforce.com, and others. Both these examples have access to and store personally identifiable information. Both, as global companies, have a full understanding of the prevailing data regulations in the countries and the United States, the US states, where these regulations exist. I actually do hypothesize that the proliferation of embedded AI will create a sense of urgency for more robust data privacy regulation across the states in the US. Let's see if my hypothesis proves out to be true in the coming months and possibly a year. So the fourth principle is safety. AI systems must be designed and developed with safety in mind. For example, self-driving cars must be designed to prioritize safety over a vehicle owner's convenience. That's an easy example because there's a physical, tangible outcome that is immediate if this principle is not adhered to. By the way, this is the one that ChatGPT came up with. So that was an easy one. What, though, is the intangible safety guardrail for AI or generative AI that may be unsafe because of the incorrect, unethical, or harmful suggestions or conclusions it derives? We've all heard the stories of AI hallucinations. One that comes to mind is where the algorithm suggested the user would leave his wife for the algorithm itself. That is a pretty clear example of hallucination. However, in early queries I made on ChatGPT regarding a simple listing of high-yield savings accounts, because I thought this would be a good use of such a powerful model, I'd get the disclaiming statement telling me that the AI language model could not provide real-time data for interest rates as they are subject to change frequently. I think this is an example of a safeguard for an intangible impact that could do harm. So I know it can be done. Finally, AI systems must be fair. They should not discriminate based on characteristics such as race, gender, or religion. All users should be treated equally, and AI systems should be designed to avoid bias in decision-making. There are examples. For example, I'll bring up the facial recognition algorithms that were being trained to recognize traits that turned out to be racially discriminatory, whether that was the intended purpose or not. And that actually has been confirmed by the National Institutes of Standards and Technology. The algorithm must be trained before release so that skin tone, for example, isn't a factor that would cause discrimination. There was a 2019 Algorithm Accountability Act, which requires companies to study and fix flawed algorithms that result in inaccurate, unfair, biased, or discriminatory decisions that impacted American citizens. This bill was reintroduced to the Senate in 2022 and subsequently rejected in January of 2023. So I think there's more work to do. I think our legislators are thinking about the impact of generative AI and algorithms. And who knows what else was in the bill. Frankly, I didn't have a chance to read the entire thing. But I think it's important as mindful citizens that we engage with our legislators, write your senators and congresspeople to express your concern about this technology and some of the impacts that it could potentially have. So these are the 5 guiding principles which must be considered while developing an AI system. It is crucial to not just follow these principles, but ensure that they're enforced. And so researchers in AI should work with the government, policymakers, industry, ethicists to develop these policies, regulations, potentially enforceable laws to ensure that AI systems are ethically sound. These laws should provide guidelines and a framework for developers, deployers, and users of AI systems to follow. So looking into the future, the ethical considerations of AI systems are only going to become more critical. The speed at which AI systems are being adopted in various industries has surpassed the ability of regulators to track or keep up, in my opinion. It is time for all of us to come together and act. And we must have a multidisciplinary team that could include a diverse group of actors, such as data scientists, ethicists, legal experts, human rights advocates, and subject matter experts who would collaborate to ensure that AI systems are developed ethically. And again, there's much work to be done. Much work to be done, but I think we have a framework that has been developed with the last couple of decades from social media. So again, I think it's a good beginning and a framework that's been laid out. So I guess the question then is, I hope that with the help of these principles, we as a collective technology community will enable AI to benefit society in a responsible and fair way. The ethical considerations of AI are our guiding lights, in my opinion, for the development and use of this technology. So to ensure ethical use of AI, it is important to involve that diverse group of stakeholders. This can help to identify and address potential concerns and ensure we align with human values and goals. And additionally, regular monitoring and auditing of AI systems can help to identify and correct ethical issues that may arise over time. Again, this is an emerging technology. And so there's more to come and more that's on the horizon that perhaps we don't even know. This begs the question of who or which entity should take the lead on creating societal protections and for which sets of people. So let me highlight a few groups. Academia has a crucial role in ensuring the AI systems are developed ethically. All of you who are researchers and educators in this webinar today must ensure that AI-based algorithms are developed with appropriate transparency and ethical consideration at the forefront. Developing ethical and transparent AI systems requires a deep understanding of the complex issues of ethics surrounding artificial intelligence. Secondly, industry, on the other hand, has to prioritize ethical considerations and social responsibility. Companies that develop and deploy AI systems bear the responsibility of ensuring that their systems are safe, secure, and respectful of human rights. And companies must follow ethical principles such as transparency, privacy, and accountability, and uphold the highest standards of conduct in the development and use of AI. Ethical use of AI actually should be embedded and be a part of the social responsibility commitments that companies are building in their ESG strategies and policies. And thirdly, the government also has an essential role to play, obviously, in the ethical use of AI. And as we can see that some senators actually did try to begin that conversation, but more has to be done. They can set aside and enforce policies and regulations that promote ethical development and use of AI. Policies must be carefully crafted with input from experts in academia and industry and include provisions for transparency, fairness, accountability, data privacy, and security. Additionally, governments must invest in AI safety, research, establish standards, and initiate discussions with industry players to ensure that an AI systems, I should say, are developed with ethical frameworks. Perhaps this is a really good time to create a task force of these stakeholder groups, and perhaps there's already a task force in play at the federal level, but my thought is at each state level, we should be enabling a task force, and that might be something that all of us in the room have closer grassroots capability to impact. Collaboration is essential to address the impacts of AI responsibility. It's important to have open, honest conversations to address these ethical concerns around AI. Leaders and industry, in academia and government must come together quickly to initiate discussions on the ethical use of AI and to work towards creating a framework that prioritizes human welfare and societal benefits. It's essential to create a forum where stakeholder groups can share ideas, best practices, and experiences. We actually have in the utility industry a playbook that we could follow, where when certain plans are in place, and utilities are sort of a quasi-governmental entity because of their monopoly, where they actually, before they can enable any policy, they have to go before legislators, they have to go before special interest groups and the Public Service Commission. Is it possible that we need to replicate something similar to what we do in the utility industry when we know that a decision that a utility makes has impact on a broad audience that doesn't have the capability to make different choices? Is it possible that we need to also replicate that for disruptive technology and innovation? What we need to do is have that and continue to encourage constant innovation around ethical AI practices. Now, ultimately, everyone must play their part in ensuring AI is used to benefit society and minimize any negative impacts that unmonitored development, deployment, and use may cause. And so I lay these thoughts out before you and encourage your continued thinking on the ethical use as you're all involved in thinking about generative AI, the strong power of those algorithms, and what types of uses we have that can benefit society. So I thank you very much for your attention. I want to open up the floor for discussion, and I know that Scott is monitoring the chat.
Well, thank you very much, Maribeth. This is an enlightening talk. So yeah, as Maribeth mentioned, if you've got any questions, feel free to put them into the Q&A. To get us started, I've got a couple questions from the talk. First one is, so transparency being one of the tenets that you discussed in your framework, how would you kind of envision an enterprise organization kind of enforcing transparency? Would it be some sort of audit, or how would that work?
Yeah, I think there's a multi-pronged approach, and when we think about transparency, there are frameworks that are in place today in corporate America that ensure transparency. I would go to the accounting, the finance part of the business, right, to look at these frameworks. I don't think we have to go out and invent something completely new when we think about these tenets or these principles. So from an accounting standpoint, we have monthly, quarterly, yearly reviews of transactions and an auditing process that helps everybody understand, what the rules of the game are. Mm-hmm. I think we need to have something very similar when we think about these disruptive innovations that, frankly, we're pushing out pretty quickly. There's a lot of competition, and we're tending to push out capabilities, I think, quicker than we're able to test out the impacts. Mm-hmm. So having an auditing process is one, having a regular cadence of review, and maybe even down if we can get beyond the competitive piece of that, even right down to the code. Yeah, I think about this whole idea, and I worked in the utility industry for 13 years. And now my daughter actually works in the utility industry. This whole idea of this quasi-governmental entity, because of the monopoly that they own, there are patterns of transparency that are laid out in front of government agencies, in front of interest groups, and in front of public service commissions, which are also government agencies, and the legislatures, where if they want to implement something new, they have to be completely transparent with what their intentions are. So there are stage gates that they have to pass through. And if they have too much pushback from even private interest groups, they go back and look at their plans and make adjustments. I think the pervasiveness of generative AI in particular, these large language models, begs that we think about something on that level.
Yeah, that's actually kind of an interesting viewpoint. Do you think, though, that adding more of this sort of audit infrastructure might kind of limit innovation in the space, though? And would that maybe add additional overhead for some of these startups that are coming up with these things? Yeah.
Yeah, absolutely. It will change. And again, I am a capitalist at heart, but I know that when you have something that is this pervasive, you have to put safeguards on it. And I look back at social media. You know, my kids are a lot older. They're in their late 30s, almost 40s. And I am thankful that they didn't have a mobile device in their hand while they were growing up. The impacts on mental health are immense, and we don't even understand right now what's happened. You know, it's a backward-looking kind of impact. I think we'll learn more over the coming years. So when I think about the pervasiveness of generative AI, we have to learn from our past, or we're doomed to repeat the same, and maybe even with broader implications. Broader implications to society. So will it limit? Yes, it'll slow things down, absolutely. And I think it's interesting that some of our leaders in industry are asking for it to be slowed down. That should be a red flag. I don't think they're just doing that so that they can get a competitive advantage. I think it's because they truly understand that we need to slow. Now, if I go back to my utility industry example, yeah, it's slow to change, but look at what's happened in that industry from a renewable generation standpoint. It didn't stop anybody from creating technology. It just has stopped it from being commercially introduced. And so I don't think it'll stop smaller companies from innovating. It'll just give them a flow in which to provide their particular ideas or new uses for the technology.
So, you know, kind of around sort of safeguards, right? You know, how do you think we can actually enforce some safeguards? Because I think currently there aren't really a whole lot of laws that are governing how we are currently using this technology. And, you know, I think some of these bigger players kind of have more visibility, but, you know, do you kind of feel like, you know, if a big company is not doing it, then somebody else will and make money? Or, you know, how do you kind of view this current, you know, kind of environment that we're in right now?
Yeah, I think it's interesting. So I think there are layers, since this is a worldwide impact, I think there are certain layers of governance that should be employed. I think because we know, and our Surgeon General has finally said, for example, that social media platforms are impacting the health of our society. Perhaps, you know, we take that as a step-off pad to think about the World Health Organization, and then our government agencies in the U.S. Because generative AI isn't something that's just ring-fenced by our artificial national boundaries, right? This is across the entire world. So is it possible that we need to implement some of these safeguards with the worldwide organizations we already have established? I think it's something that we should look into. I think it also, we should call for states to create task force within their own boundaries of academia, industry, and government to talk about this topic so that everybody can start to get their handle on it. I think there's a lot of communication going out from the tech community and a lot of interest and excitement being generated without a lot of understanding.
Right.
And so, and it's fast and furious, right? I think you could raise your hand. I think we've all been invited to probably 5 or more, the symposium perhaps being one of them, right? Gatherings to talk about this topic. That's how interesting it is. But we really haven't stepped back and thought about these ethical implications. And so perhaps we should be doing something on each level of government, at a state level, at a federal level, and then perhaps at a world level, to talk about what these ethical implications are so we can safeguard society and the mental health of generations to come. And frankly, one aspect from the security that he didn't highlight is just the whole cybersecurity piece of this. There are a lot of concern about whether hackers are able to use this technology, which they will, to make detection for their threats even harder, because they're learning, right? They're learning how to move around the safeguards that we've put in at our companies and even in our personal accounts. So it's just really behooves us that we pay attention to this. This technology in particular has a lot of potential for good or for evil.
Yeah, no, I completely agree. I think even, recently from a research perspective, a lot of the platforms that we've been using for human subjects in our research has actually been these AI agents that fill out surveys. So even the data that we're getting, that we're making, decisions based and, writing papers on, is even being synthetic. And, we're starting to see this be a problem in academia as well. With that, also another question. So currently, there are many open source projects that have open versions of LLMs and other generative models. I think about Midjourney as being one of them, but Facebook also opened up their Llama model. Do you think that an open source community can exist in this arena and adhere to these frameworks?
Yeah, that's a really good thought. So I think if they were just on their own, perhaps we'd have the fact that it's open source and there's some amount of transparency, I think helps with the argument that I'm putting forth. Do I think that they and themselves can achieve the social safeguards that I'm speaking about? No. I really do believe this has to be a collaborative between academics and researchers, industry in particular, whether they're using open source or not, and of course our government. I really do. This is a point of inflection that these bodies need to come together, because we don't want to have some sort of a disaster, frankly. And honestly, with the social media platform example, it's a slow burn that is creating a disaster. It's like the boiled frog example, right? We didn't turn the heat up and the frog jumped out. No, this temperature has been raising over time. And so it's not like we can respond to this and all rally around it as humans because we know there's an event that happened. And so we have to create some sense of urgency, but come together as those 3 different groups of people. But I think open source actually can serve a purpose, because it should create more transparency, and we should have communication around that and have conversation about the safety of some of the pieces of the algorithm. Absolutely.
So, if you were to kind of imagine a world that is a little bit, more ethical with its applications of AI, would you see this being a technology that's more democratized, or would it be in the hands of a few players that we could sort of audit and ensure is transparent, or, kind of what is your thought on that?
Well, so again, when I think about, and I made reference to few people having power, unfortunately, in my opinion, is never good.
Right.
We have historical markers of people who've had a lot of power and have wreaked a lot of havoc. I think Hitler comes to mind, right? I'm not saying that somebody who's got market monopoly would go to that route, but I think we are definitely at an inflection point in technology if it's so pervasive and so strong that we need to democratize it, absolutely, and then manage it in such a way. Now, that thought actually works against my my capitalist self. Believe me, I've had some real internal arguments thinking about this, because I'm calling for something that typically goes against the capitalist way of thinking, or even a more libertarian, independent way of thinking. But that's what I think is important. This technology is so powerful that it calls for democratization, and with that, monitoring in a way, just like a utility, right?
Right.
To me, that is a really good analogy about the management of such a powerful influence in society. Think about, whether you have electricity or you don't. They serve society in that way. I think this technology has gotten to the point of pervasiveness that we should be thinking about it just like we think about electricity.
Yeah. No, I think that's a fantastic analogy. So.
Yeah. I think there is a question in the chat.
Oh, okay. Let's take a look here. Yep. Let's see here. Doesn't look like we've got one.
No. Yeah, I agree. It's reminded me of the Social Dilemma documentary on Netflix, must watch if you've got teenage kids or are worried about social media impact. Deepak, I agree. I did watch that, and I turned off all my notifications on all my social platforms. And actually got off of Twitter for a while because I really don't find a lot of value in it. But I agree with that 100%. Thank you for that comment. All right.
All right. If there are no other questions, thank you so much, Maribeth. This was a very enlightening talk and a fantastic discussion. And now we'll be segueing into a brief break before we get into Rajesh Gupta. Thank you very much.
Thank you very much. I appreciate the opportunity to speak with you. Enjoy the rest of the symposium.
Thanks. All right.
Hi, how are
Hello,
you,
Rajesh.
Scott?
Great, great. So it is my pleasure to introduce Rajesh Gupta. Rajesh serves as the founding director of the Halajalu Data Science Institute and as a distinguished professor of computer science and engineering at UC San Diego. His research is in embedded and cyber physical systems with a focus on sensor data organization and its use in optimization and analytics.
Excellent. Thank you, Scott. And thank you for inviting me to this seminar, webinar. And thank you, Dean Kaushal-Chari, for pulling together this program. It was a fascinating talk to hear about ethics and explainability by Mary Beth Achterberg. Quite engaging and important topic. I'm going to start sharing my screen. Just give me 1 second. I hope you can see that. All right, thank you. So a couple caveats I want to give about this talk, it's quite a bit of work in progress in terms of the work that I'm going to describe and how the area is developing in last, I would say, 12 months to 2 years. It's not a tutorial on ChatGPT. It is built upon the concepts and advances that the modern AI has brought together. And what I'm going to do is start with a bit of a background about the background in which this research is placed, and why we refer to it as a real-world learning, what is changed. You'll notice in terms of my affiliation, I am professor of computer science. I am also founding director of Halajalu Data Science Institute. And I'm going to start by first giving a little bit of an overview of the institute itself so that you sort of have an understanding of the nature of the work that I do and the nature of the organization, and that sort of is driving this research area. Very briefly, like any academic department units in a modern university across multiple schools and so on, we have created the data science as an academic unit, which is like another school. There is not quite another school yet. It actually has engagements pretty much with all areas of knowledge within the university. We just saw a talk on ethics, and here you look at the topic that touches upon from humanities to engineering and sciences and so on. And just to give you a bit of a history and the context for that, it has been my honor to lead this effort from early days when I was chairing computer science. And one of the first things we did was we built a computer science major, a data science major in 2016 that was approved and launched in 2017. The institute itself was built, was announced in March of 2018 officially. And there were initial faculty appointments from various departments before we started recruiting our faculty within the institute itself. We had our first class of graduating students in 2020, and tomorrow there will be our fourth class of graduating students. In the meantime, in the last 5 years, we have built both our graduate and undergraduate programs and masters and PhDs in data science, and recruited a number of faculty launched in our research institute. So if you look at the faculty, just as a sort of a spread of the areas, there are 7 different areas that sort of come together as data science. It's kind of a busy slide. I don't expect you to read all of it, but just focus on the topical focus. And it goes from theoretical foundations, algorithms, and optimization, probability, to physical sciences like environment, to accountability, fairness, human interfaces, to bioinformatics and health sciences, and so on. So it is truly a very large interdisciplinary topic that sort of has emerged because of the advances in machine learning and AI in recent years. Today, now we have recruited 28 new faculty members, a total of 17 faculty members, many of which have joint appointments. I'm going to list read all the names, but philosophy, communications, medicine, and so on. About 1,000 majors and another 200 or so graduate students. We also have an online data science program. So this is sort of now you can think of it as a large scale department, for example. Coming to the topic at hand, which is embedded intelligence. This is what I'm going to describe is the work done in my lab. It's called MESL, Microelectronic Embedded Systems Lab. My students focus on, and currently, quite a bit on how the intelligence systems embed in physical systems, whether it's electricity grid or transportation or buildings or water distribution systems and so on. And so there is quite a bit of sensory interfaces that go with them, as well as a real-time decision making that must be done in order for the systems to be effective. So what I'm describing in next hour or so is really going through the research that my students are doing. Here is my thought line for the talk and the topic that I want to touch. As I mentioned, that embedded intelligence is really about embedding logic and intelligence, embedding decision-making in real-life systems and applications. Our real-life systems is an infrastructure, a set of infrastructures from cloud to internet to communications to transportation that is evolving rapidly. So I'm going to touch upon a little bit about what these infrastructure elements are. And I'll give an example of how the infrastructure enables human spaces, basically buildings and smart cities. And then that sort of sets the stage for understanding why the context is so important in intelligent interactions with the real world. And context is at the core of modern advances in current AI, whether it is transformers, whether it is attention mechanisms or self-attention mechanisms. And so how do we get to the context? How do we capture that context? How do we reason with that context? And I'm going to focus in particular on sensory data as opposed to images and videos and so on, and how it is different and what are the challenges it presents. And then go a little bit into the technical details about how the sensory data can be handled. I won't go all the 3 topics of efficiency, timing, and but focus a little bit on touch specificity, because that allows us, for majority of the audience, to connect to what they experience in their real life. I've always tried in my talks, no matter how technical they get, is to get to a basic message. So if you were to stop here and see what the summary of this talk is about, there are three takeaways, and basically these three themes that will come up and reappear through the examples and so on. And the three takeaways are, first, the sensory information is more than data, and it is different fundamentally from text and images. For example, when you look at a picture of a cat, no matter which environment that the cat is placed, the object cat remains a cat unless you do some adversarial reasoning and so on. But sensory data is a set of numbers against a timeline, and it can present very different picture depending on the context in which it is placed, and that too can also change dynamically. So sensor information is more than just data itself. And the second is that the information itself is not, it doesn't exist outside of its purpose. In other words, information and purpose are so intertwined that one must understand the purpose. And this goes all the way to philosophical reasoning in languages, most notably Wittgenstein, that your power of reasoning is limited by the language you use. So it is not just encoding of knowledge, it is knowledge itself. And so one must understand the purpose for which the data encoding information is being collected or used. And that sort of will appear as a task of specificity as we go forward. And for purpose, for understanding purpose, for understanding intent, context matters. And so context now has emerged as a big driver of innovations in modern AI. The infrastructure that drives our current interest in advances in machine learning and artificial intelligence is very familiar to all of us. We hear often about cloud computing, and a picture of a large number of servers, noisy servers in some remote far-off location consuming a lot of electricity emerges in the mind. And these large computational resources are made accessible through a series of networks, which is the second infrastructure called the internet, or the network of networks. And this internet, as it has become multi-radio and multi-point connections, it is accessible on a variety of platforms, from desktops to mobile devices to even what we now know as edge devices, or the devices at the edge of the network. And the edge devices are increasingly part of our sensing infrastructure. So sensors are not just temperature, humidity, or electronic sensors. People are sensors. People with cameras are sensors. Cars with maps and directions and their destinations are sensors. And so we're beginning to see devices with IP addresses at the edge of this vast network. That sort of also forms an infrastructure. And what has come in between, most notably, and this is something which has been both a delight as well as consternation for many parents, is the platform of mobile devices, iPhones and Android devices and so on. And somehow this black screen has become a sort of an integrator of sorts, an integrator of not only the endpoint devices, but also our lives, who we meet, when we meet, who we talk to, what we record, what we attend to. It has become almost integrated with everything, but it would not have been possible without the cloud and the internet infrastructure. So if you look at this platform of capabilities that this device brings together, you notice that it in almost all cases there is sensing, but there's also actuation. There is also actuation could be an email being sent to some equipment being flipped on to something being monitored, like your Ring device or your um, uh, cameras as a security cameras and so on. So we call these loops of sensing from edge devices to reasoning to taking actions as perception, cognition, action. And of course, action itself might change the reality of what we see. We move the camera around, for example, or turn on some devices, turn off some devices. So these perception, cognition, action loops are now emerging as the greatest manifestation of artificial intelligence today. And they're happening in multiple levels. The cognition action loops you might see, for example, when you're driving or automated driving, for example. But that's not the only one. In fact, the next slide gives you a number of examples of such loops. Um, uh, uh, whether we look at the platforms of automated car, where the perception is through radios and cameras, radars and cameras, and the goal is to understand the scene and take actions for the moving vehicle. Drones or smart buildings, for example, that look at energy consumptions, occupancies, health conditions, and control airflow, control energy usage and so on. Same thing with respect to power grid and so on. This is where nation states are becoming much more interested in making sure that these are robust. And so these loops span from individuals to infrastructures. Okay. Apologize, I should have somehow found a way to turn off these notification systems on my machine, but anyhow, so when you look at these platforms, what you see here is in these perception, cognition, action loops, computing is embedded in all of these. Networking is embedded in all of these. Reasoning and AI is embedded in all of these. But you don't see a computer. In fact, computer is not even the primary object here. And it turns out that new platforms are emerging for computing, where the computing paradigm itself is being generalized. You can think about, just like you think about desktops and laptops and your mobile phones, you can think about a building being a computer itself with a set of resources, have some connectivity, and has some policies and programming, just like an operating system would have, that govern the use of its resources and control of these resources. So they're enabling new types of applications. And when you look at the new types of applications, you start to notice there is even more need for generalizing the abstractions we have gotten used to. For example, when we talk about data and computing systems, we understand exactly what that means. Data has a location in the memory or in storage, and it usually consists of something, let's say a byte of data or a word of data to megabytes of data, packets, and so on. But what about data about data itself, the data that classifies the data itself, or the data that might come with some restrictions on that data or policy of use? So the data about data or metadata is actually becoming more and more significant. I'll give you an example of that going forward. But without metadata, data may not mean much. If I give you a sensory data from, let's say, a motion sensor or a gyroscope, it doesn't mean much without knowing on which system this was placed and what time it was collected and so on. So the metadata is one means by which the capture and the context is captured. And not only context is captured, sometimes the context may itself need to be changed based on what data is being collected, and so on. And therefore, the data and metadata are causally connected. Sometimes it's known as a reflective interface, but the idea here is that, let's suppose the metadata is about temperature of your mobile device, let's say your cell phone. And if it goes very high, you leave it out in the sun very much, then somehow the machine needs to now throttle down its activities, even shut down based on the temperature rise. So the metadata actually acts upon the operations of the machine. And sometimes the metadata itself might be changed through what are known as introspective interfaces by the data being computed or collected. The other challenge we run into is when you look at a modern platform, let's say a set of cell phones or number of users inside a building and so on, the data is not neatly organized and available in some address space of a computer as it is in an address space of a computer or in the storage space of a cloud. In fact, you have to discover whether this particular data which location it consists on, or if this particular sensor is on which device. So discovering a resource is equally as important before the resource can be put to use. And resource discovery is a core capability for the new platform that sort of we had taken it for granted when we talk about computer programming, for example. Then we have a whole host of challenges related to trust and trusting and availability of data. Just because data exists on some platform doesn't mean it is accessible, or even it is accessible by policy, not by technology. And what that means is that there are data sets that you have on your mobile phones as sensors that may be useful for some AI determination, but that doesn't mean the AI must be able to access it. And therefore, you need new means of learning from the data without compromising, for example, privacy. And the whole areas of federated learning that are emerging are actually trying to solve that problem. And this trust and responsibilities can also be dynamic. We are inside a building, we have some set of responsibilities. When you're outside a building, we have a different set of responsibilities. And so we have to look at the data and security and privacy and what we do them very, very differently and in a new way than what we have been used to in computing systems and computer science. Which has made tremendous advances in the last 30 to 40 years. Computational problem solving has become a core capability for majority of us in engineering domain. Are we? Is there a question?
Nope.
All right, thank you. So we have built a whole bunch of abstractions like finite state machines to Turing machine models, to parallel RAM models, and so on, that we teach computer scientists to reason through and build the technology base upon which the modern advances in AI are built. And we know which set of problems can be solved by computers, which problems cannot be solved by computers, and in terms of decidability, and which problems can be solved efficiently, and which problems cannot be solved efficiently unless some long-standing technical problems are solved. But when we come to embedded intelligence embedded in real life, it is not enough to simply say, take the computer, make it smaller, and put it inside another system, whether it is a car or an electrical cell grid or building, even though this is precisely what we have done in the past. And the reason for that is are technical. In other words, computers perceive reality in a certain way, and that doesn't mean it actually applies to real life. A classic example is if you have a flight simulator and you're flying a plane in your flight simulator, it can be very realistic with all the control. But it also has a pause button. When you push the pause button, the time stops and the plane hangs in the air. If the same control system, the same software is running on the actual plane, you don't have the ability of a pause button and the plane will come crashing down. So the reality, logical reality, is not necessarily the physical reality, but it must interact the two together, and sometimes enhance ones against the other. And that poses a number of technical challenges that my group has been working on for the last 30 years or so. And so the in all of these, the intent and context is again important. Let me sort of give you that as an example. But this has been a business as usual for quite some time. What has changed? And I was listening intently to Mary Beth's talk about explainability, and we understand what explainable systems are. Explainable systems are, if you buy, let's say, one laptop for $2,000, then two of them will cost you $4,000. They don't cost $8,000, for example. We understand linearity, they are explainable. We understand that if the dimension goes up twice, the area goes up 4 times, that's quadratic increase, but we understand that's explainable. So in fact, all our learning in education has built upon explainable models, which were symbolic in reasoning. And that symbolic reasoning has allowed us to understand physical reality in ways in which we can reproduce the intended effects through our devices. And much of engineering advances have built upon those explainable systems. There is another class of computations that have emerged that had been around for the last 30 years plus, but they have made significant advances in most recent years. And that started with neuromorphic processing. And the neuromorphic processing, initially a curiosity built upon trying to mimic how human brain looked under the microscope, and based on that, creating some kind of a compute engine, thinking about human brain as a compute engine, for example, which is not the case. But curiously, as we understand these neural computation, we are actually beginning to understand human brains also better. And those advances in how the computation was structured essentially followed a very simple path of creating architectures. We call them neural architectures that sort of had layers of processing on input data that was assembled through external interfaces. Initially, the problems that were sort of addressed through this, and you can sort of model these in classical symbolic terms by using metrics operations, for example. Beginning about 15 years ago or so, two things happened. Of course, one is internet, rise of internet that allowed availability of larger scale of what we now call annotated data, picture of cats and dogs and so on. But even more importantly, a large amount of parallel processing became possible. And you can imagine each of these processing nodes, neurons, as another computer, for example. And that allowed us to, we started to see something. One of the things we started to see was that when we did this neuromorphic computing, patterns were easily detectable. And the patterns, our ability to detect patterns became more and more sophisticated over the years. And it became more sophisticated as we increased the number of neurons and the number of layers of processing, and which is why it is sometimes referred to as a deep learning, because it has a larger and larger number of deeper layers of processing that sort of increased. So hidden layer 1, hidden layer 2 kept on increasing. The earliest advances that we recognized a couple of years ago with the Turing Award to the inventors was handwriting recognition, but pretty much anything that had a pattern, no matter how complex it was, they were becoming accessible through a whole bunch of innovations that sort of related to how these sophisticated these architectures became. And we started to give names to these patterns as features. Sometimes the features were even inside intermediate layers, for example, that we could intercept and maybe even guide them through sub-selection of important sub-features, for example. So today we have come to a point where the neuromorphic architectures have made it possible to detect these patterns, and they have two very important characteristics. One is that they are robust against incomplete information. So they operate and achieve the results of whatever the end goal is, handwriting recognition, speech recognition, etc., etc., even when the information that is being presented is not quite complete. And the reason for that is it always produces an outcome, unlike a piece of code where if a control procedure is not known, there is no termination of the program, for example. And the second interesting aspect is the ability to generalize. In other words, something that looks closer to approximately what it has seen before, for example, it could point to that. And that ability to generalize and apply incomplete information was the biggest source of strength, but also biggest source of pain as we go forward. And so what we talk about as hallucinations and so on really is built upon those fundamental capabilities. And from the way I look at it is hallucinations are really actually a feature, and it's just that we sort of use anthropomorphic terms and give an interpretation and call it an hallucination. But in reality, it is really reasonableness criteria being applied in a neural network. But we'll get to that. That was going on up until 5 years ago, more like 6 years ago. And we sort of had in those 10 years of development, we had gone from being able to discriminate inputs, for example, look at a picture and find out different parts of the picture by first training the neural network and then discriminating an output, creating a discriminative output. These were known as discriminative networks. And these discriminative networks basically a neuromorphic processing, basically went through a supervision phase, training phase, and then use phase or inference phase. Of course, the training became a big problem in many applications. We didn't have much training data in some applications and so on. So there was a constant attempt to reduce the amount of training or amount of supervision. And we said, well, we could, for example, have one network train the other network, or one network simulate or play a game, for example. And that sort of started to the architectures where a discriminating network was in the feedback loop of a network that was generative. And the generative networks where the input is really a prompt, or could even be a noise in diffusion models, which allows the network to sort of take a guess. So instead of recognizing a cat, you ask a network to draw the picture of a cat, and then you feed it to a discriminative network. Does it look like a cat? And you sort of do it a few enough iterations, and you start to converge into something that looks like a cat. So putting these networks together became then a class of networks called generative networks. And within the generative networks, certain algorithms arose that sort of improve the accuracy of this, the ability of these networks to generate. And these were known as GANs, or generative adversarial networks, because of a game that they play between the two networks. And they have been used for cleaning up old movies, creating photorealistic images in motion, and reconstruct 3D models and so on. So that was all great. Up until 6 years ago, these two set of networks were dominating conversation, both in supervised learning and also in weakly supervised or even unsupervised learning. Then in 2017, a set of researchers at Google Brain came up with another way in which the computation burden of discriminated networks actually could be reduced. We were trying to reduce the amount of convolutions we needed to do, the amount of mathematical operations we did by by focusing or reducing the amount of computation inside in the matrix of neuromorphic computers. And that was the concept of attention. If the neural networks were trying to mimic the brain, the attention was trying to mimic what happens in real life as we think about things and doing attention. So the brain's attention mechanisms were being mimicked in attention. And it turns out, and this was a key paper that came out, that that attention was actually much more significant operation than the neuromorphic processing itself. And so this paper, Attention is All You Need, in 2017, sort of started a chain of thought and thinking that sort of has led to today's advances in large language models and so on. So we had three very distinct phases. One phase was just algorithms that allowed us to do optimizations, for example, to architectures, which were neuromorphic architectures, to now what we call foundation models, which sort of focus on functions. And this is where attention mechanisms and self-attention mechanisms are becoming key. The whole movement towards attention was really driven because of the efficiency, in pursuit of efficiency in computations in neuromorphic processing, and parallelization. It turns out the neural networks or recurrent neural networks had a deep alignment requirement of the data as it is fed into the matrix of neurons. It has to be aligned to sentences or scenes and so on before any inference can take place. In case of attention mechanisms, the data carried its own indexing. So, for example, if you give a sentence, the order the order in which the different words appear in a sentence are part of the data. So this is word number one, this is word number two, word number three, and so on. So this position in coding of the input information as a part of data made it much easier for us to build attention mechanisms, which you can think about as matrix operations, but giving a structure to the matrix of neuromorphic computers into three different parts. Those parts are not important; they're given now new names, but basically that allowed us to sort of reduce the need for supervised learning. Especially since we could be looking inside each of the sequences, a scene or a text and so on. And that has led to modern AI, where there are three kinds of problems. I'll just mention very briefly what these are. One is detecting patterns. And like I said, detecting patterns, whether it is speech or text or image or video and so on, or medical images and so on, have matured to the point where now much of the research has moved towards trying to explain why it works so well, and when it does not work, what the reason could be and how it could be generalized and so on. Automation is a more difficult problem. For example, driving your automated car and so on. That requires not only detecting patterns, knowing the data, but also taking timely actions in tight feedback loops. And those feedback loops may even include humans. And that's based on actuation and interference from users and so on. These have much higher safety requirements and trustworthiness, much higher requirement of repeatability, for example. And therefore, the progress in automation is happening, but not as fast. And the third level is inference and cognition, where surprisingly a much significant more progress has been made. Though, of course, much higher bar of success, because it sort of touches upon our society and our people and how we think about us and ourselves and so on. Sometimes it's also referred to as general intelligence or artificial general intelligence, but that's a debate we shall not get into. Oftentimes people think about AI more like not artificial intelligence, but more about augmented intelligence or intelligence amplification, or IA. The cognition parts requires reasoning through uncertainty, and I've already said that neural networks or neuromorphic architectures were very useful in uncertain data inputs or incomplete data inputs. But the applications of these, especially in inference and cognition, as tempting as they are, can be very challenging, especially if reasonable assumptions being made by the neural network can actually appear as hallucinations. And the reason they appear as hallucination is also a play on words, but basically because we trust the outcome so much without realizing that it is really a search through a hyperspace of text and their connections between them. All right. So coming to sensors, interfaces, and so on, let me give you an example of how that reality is going to be changing our world, and then I come back to more underlying AI mathematical side of artificial intelligence. We are all very familiar with commercial buildings. These are our workspaces, and you walk into a building today. It is a complex connection of HVAC systems with a very large number of fans, dampers, thousands of lights, security, temperature control, air control, and so on, security control, and so on. So, so I said, well, you know, is it possible to think about buildings in a more systematic manner, as if we think about computers, for example? And we said, well, here's one way to think about it. You can think about the information that is coming from sensors, and that you sort of have to use that information to navigate yourself in a building along with maybe 100 others. Or you can think about it or structurally, where you have at the lowest level a set of sensors. It could be temperature sensors, carbon dioxide sensors. So carbon dioxide is usually a proxy for occupancy. So it is surprisingly very good proxy in the sense that carbon dioxide concentration can tell you how many people are in a room. And this was extraordinarily useful, especially during COVID times, because we could then control the amount of occupancy and sort of the potential health adverse effects that can happen. Occupancy can also be directly determined through passive infrared sensors or PIR sensors. And then these are organized into subsystems, whether security, HVAC, lighting, server rooms, and so on. And then you have applications that run on top of that. Applications can be, for example, controlling the environmental conditions, airflow, temperature, and so on, detecting fault in the equipment systems, and adapting to energy use policies, for example, whether we are in a energy constrained or cost of energy scenario, whether it is a different time of the day, and so on. So we said, all right, can we sort of pull this together and build a software stack where we have at the lowest levels infrastructure sensors, and at the highest level we have applications. And this is the work that my students have been doing for the last 15 years. The number one challenge we addressed was, first of all, how do you even address buildings to get the data? If you say activate AC when this room is occupied, how do you get to it? On a computer, it's very easy. I know the address of every data items or program items. I can issue an instruction to write or read from that location. But how do you do that in building? Now, while we were solving this problem for a building, now you can, with a small stretch of imagination, you can imagine that as AI becomes part of our daily lives, this problem is now common to transportation system. This is common to smart cities, is common to pretty much every smart infrastructure that we can think of. And so we worked on this problem by actually creating a schema that has now become a standard schema it's called brick schema, which sort of uses software engineering innovations to define an object-oriented model for for various metadata tags, if you will. Metadata can refer to the location or zone. It can refer to a parameter, physical parameter like temperature, humidity, etc. And so these tags, which were sort of hanging around on our control systems in buildings in the past, sort of has become a significant part of a metadata structure. And we sort of also build a relationship between them. So for example, an air handling unit has an instance that feeds into some variable air valves, which feeds into some zones that has a whole bunch of rooms, for example. And so you have a point class, which means a control point, a location class, an equipment class, and you now have a language. And that language allows you to do a whole bunch of things. I'll give you one example. You can build these applications on top of buildings as you would on a computer. So you walk into a building, your mobile phone is actually talking to the building operating system, just like your mobile phone is talking to the wireless networks. And it is not only announcing your presence to the people matter, but it is also guiding to where you want to be, setting up the spaces and so on. So a whole bunch of technologies that come together that sort of allow us to put the internet infrastructure to use. But of course, because it is a controlled, sensitive infrastructure with security implications and so on, the intranet or the industrial control network is actually isolated with some security mechanisms from the wide internet, which of course makes the whole program thing accessible. So you can do things like, for example, we have installed, here is a typical air handler you will see on top of a roof or at the basement, with sort of an air handling unit that sort of pushes the data, the air, conditioned air into local zones, for example. And you may have a situation, for example, where you say, in a particular room, set up the set point of air handling based on its occupancy. This was the #1 application we put to use across the entire campus during COVID times, where we wanted to improve the airflow just before the room got occupied, and as this increase went, and then drop it down when the room was emptied up. Why? Because the cost goes pretty significantly, almost cubic to the cost of air handling. And so we said, okay, here is a occupancy. We have the occupancy sensor, CO2 sensors, and so on, and we are now controlling the amount of airflow. And you can actually do that by basically writing a program. I will skip the actual program language, how it is done, but that program allows, this is the entirety of the program, that allows this particular zone to, for example, have a dynamic airflow condition. So for example, this is over time, and each of these boxes is 1 hour on the x-axis. So for 2 hours before the room is occupied, you can precondition it to air handling, for example, air change per hour to be up to 20, which is better than any hospital environment. And you could actually run the classes without worrying about infection spread, for example. Even though we are now past the pandemic, the health conditions inside the buildings from flu and so on require us to actually pay much closer attention than we have ever done that. And so you could now do a zone level or a room level or a conference level air handling control that is dynamic and also energy efficient. Just in case you're worrying that if I were to just increase permanently, what will be the energy cost? It's usually 3 times. So a typical building which costs about $4 per square foot per year in electricity cost in the temperate West Coast, for example, probably Midwest is higher, could easily be a 100,000 square feet building could easily be going from $500,000 a year of operating cost to $1.5 million of operating cost. So these costs are significant, and they scale up as you scale to the scope of cities and campuses and so on. So coming back to real life and to AI, from just this example, as you look at the sensor data today, it is significantly expanded. I'm pretty sure anytime you pull out your phone, there are 2 or 3 radios that are active at any given time. You turn on, you of course have your cellular radio, cellular connection, but you also have a Wi-Fi, and probably not one, but many. But have you think about this Wi-Fi networks? You're basically looking at 2.4 gigahertz or 5 gigahertz signals bouncing off you and everything else all around the buildings and around the spaces. That's almost like lighting you up, and they could easily be imaging you. They could be imaging your health conditions, for example. So we are beginning to look ourselves and our environment at multiple frequencies. Now, these radios, which are meant for interconnections, can actually do more than that. I just mentioned imaging, but you now look at 5G and technologies which are in a 60 gigahertz band, or even going up to terahertz. Those radios are also on the horizon. And now these radios, as they bounce off, as you increase the frequency there, they also have a skin depth. In other words, they can look inside past just the surface, unlike optical sensing. And just like ultrasound, for example, looks inside the tissue. And by changing the frequency, you can actually control the depth at which you're looking at an object. So for example, you can have a non-invasive robotics where the robot can look underneath something that could be occluded by optically, for example. So you can have radios tomorrow that will light up the objects through radio waves, for example, and then look at using a radio frequency or photonic, which is optical, or electron sensing. Hopefully not that much, that is more in medical settings. So suddenly, each of these radios, each of these imaging is creating image of the environment or the surrounding, and in the process generating significant amount of data. So when we sense our environment, the sensing can be significant, and that allows us to do with not sensing of spaces, and of course with a time base, and therefore we call it spatiotemporal. And you can do things like human activity recognition, whether I'm sitting or standing or walking or lying down on the floor, or is my heart rate high or very high or not even beating. Similarly, motion tracking. And so converting all of that information into data and then sending it to some remote cloud for processing is just not possible. There's just too much data, even before we get into privacy and other issues. And therefore, we have to now distribute the processing at the endpoints or the edges, as well as on intermediate platforms. We also have to think about why are we even collecting that data? What use will that information be? Of use this information will be. If I just want to count the number of people, perhaps an oxygen, carbon dioxide reading is enough. I don't need to take a picture of and take information about the identity of the people, for example. So the specificity of the task that you want to do with the sensory data is an inherent part of artificial intelligence that will be used in real life systems. And so just to give an example how this word of collecting information is changing, there's a classic problem in sensor placement of placing sensors optimally for whatever application we want to run. For example, in a typical conference room, you will see an array of microphones and an array of speakers. And you want to make sure speakers are people, for example, and microphones are so here they're modeled as transmitter and receivers. You want to make sure that you're able to hear the conversation, especially a distributed conversation well, or record it, for example. Typically in the past, you would do that by doing signal to noise measurements at each of the receivers and doing placement such a way that the signal to noise ratio is maximized, for example. But it becomes harder and harder as geometries become more complex, different materials are used in buildings and conference rooms and so on. So I had a thought at that time. I said, well, why not we simply put a recognizer or a speech recognizer instead of looking at the signal to noise ratio, and then use the error in speech recognition to drive down the neural network to do this placement problem. And it turns out that when we did that, instead of looking at the signal to noise ratio, but actually speech, where we could determine the location. And what you're looking at here is a experiment of sensors, transmitters, and receivers. Different locations have different encodings, for example, which is on the right-hand side here. Different locations give you different word error rate. For example, there are two different ways this error rate is calculated. One is using online using clouds, and the other is on the edge at offline, which takes a longer time. So you have different machine learning models that sort of generate the probability of what the character was heard, for example. And it turns out when we did this, and the system that we built called SQUI, performed better than any of the signal to noise ratio estimations, and that too very rapidly. That means very small amount of conversation was heard before it actually found the right parameters to find the sensor placements and use the right set of microphones for listening to any conversation. And that sort of got me thinking quite a bit as to it applies to all real world challenges, where if we start to look at the not only the task but also at a higher cognition level. So for example, when I walk into a room, I feel hot, cold, or warm, and just that sentence or just that word is actually important sensing information, and it could even be more effective than using a temperature sensor, which sort of has a threshold value that is being used in the control systems. So can you build new kind of control systems? Can you build new kind of reasoning systems that move away from parametric space that has underlying engineering systems to a space of labels, a space of languages that is used for sensing and inferencing purposes? That has been essentially the sum total of the research we have been working on. When you look at the mobile sensing data, for example, such as embedded mobile sensing, you might be very familiar with pretty much every device today has some kind of a inertial measurement unit, IMUs, and they basically generate a time signal, usually an accelerometer, over a waveform over a time period. So you can look at each time period as an index or a label. And so therefore, all the data has a strict ordering that's known as a time series. And we routinely do this training of this IMU data, which sort of tells us whether we are sleeping, whether we're snoring or turning, or is it a light sleep, deep sleep, or we are running, and so on. These conditions are very dynamic. If you look at the waveform, they don't tell you much. It is a combination of waveforms that sort of allows us to detect the category of motions, for example, we're doing. We are beginning to augment, for example, IMUs with other additional informations, let's say radars, Wi-Fi, and so on. This human activity recognition presents its own challenges. One of them I told you is that when you look at the data, the context determines what actual activity it represents. In other words, the same data with a different context can give you a totally different inference. And so it is not surprising that when we look at the time series data, unlike text data, unlike image data, unlike speech data, and so on, the research in this area has been 2 to 4 years behind in terms of the methods that have been used. So CNNs, or convolutional neural networks, for example, were used for speech recognition in 2012, whilst they were used for IMUs in 2015 or so, 3 years later. Same thing, GANs are about 4 years behind. And most recently, the transformer models are just beginning to appear in the last 2 years for sensing data. And I'm going to describe one of those transformer models and how it is done. There are certain challenges compared to the data that we're used to. One is there's not a lot of labeling. There's a lot of data that you may have from sensors, but there's not a whole lot of labeling that goes with it, because labeling is a human activity oftentimes. Sometimes there's no label data. If you take a medical data, for example, it actually takes a specialist before a label can be attached to that data as to what it represents, and therefore it is even more sparse. And so when you look at the traditional model of taking time series and converting them into some bunch of features and or hierarchy of features against which we build a model, let's say LSTM or some learning models or machine learning models before we can sort of make inferences, it just does not apply to this data. In fact, the challenge with machine learning on this data are in three categories. One, sometimes there's not data available. There are gaps in data, maybe because some devices are not working, some sensors are not working. Sensors usually are not always operational. They might be duty cycled in terms of power cycling. Sometimes the sensor may be operational only some part of the time, and some other part of the time the sensor is not operational or not active. For example, daylight versus nighttime. And similarly, your data could be pretty heterogeneous. The same phenomena is being looked at multiple sensing modalities. And then, of course, the data could be very specific to the activity that is being presented. A number of works that we have done and others have done in trying to overcome these challenges. The most common is data sparsity or lack of data. In case of data sparsity, oftentimes we use a generative model to fill in the data as if there's another process that acts like that generates the data. Thank you very much for the time. It should take me less than 5 minutes to go over that. And these generative models sort of are filling in the data and the samples that are used. We have been working on augmentation methods to allow us to do this data lack of data. One way we do that is by actually looking at what the data is being used for. So, for example, if you have a bunch of sensors that are used, for example, for determining the amount of occupancy in a building, or another task could be the amount of energy consumption. These are two different tasks, and therefore the importance of one type of sensor, for example, occupancy is more closely related to carbon dioxide, while energy consumption is more related to temperature, because that will turn on or turn off the HVAC system. So based on that, you can create new methods to do that. I'll very briefly mention the transformer, which that sort of have been put together. The transformers are at the heart of, for example, today's large language models. They are based on the encoding of various pieces of data. For example, various pieces of words in a sentence. It can focus on the for any given word or for any given piece of data, what is the most important context against which this data is placed. So we do the similar thing with respect to time series, where we build a self-supervised pre-training networks by taking the time series data. I'll skip exactly how the transformers actually work from a matrix point of view, and we built a network called TARNet, which is a reconstruction from time series data based on the importance of the end task. And it turns out that these, if you do a task specific, it outperforms any of the known methods today. So just rather than going into the actual architecture, the reconstruction and the focus attention, which is specific to what the end task, is a key part of both the architecture as well as the algorithmic advances that we brought together in transformations. Let me put this all thing together and sort of paint a picture for you with respect to where the sensing data is going. If you look at the sensory interfaces and the communication channels that follow that, and the networks, and then the cognition, you can think of it as a one integrated pipeline. Now, we are very used to symbolic reasoning, at the highest level, at the language level, where we know what we want to do. But if you're driving a car, whether we want to turn left, right, accelerate, and so on, these are words. But the right-hand side, the sensory interfaces are all physics-based. Now, we are entering a period where the metadata and the labels can propagate down this stack all the way to the sensory interfaces. And instead of collecting the numbers, we could be collecting, for example, how many people feel hot in a room or cold in a room, or how many people are moving left, right, or sleeping in a room, and so on. So the language level models can be pervasive in the entire sensing, communications to processing chain. And that is sort of the work that I see happening in next 5 to 10 years. When that happens, you're gonna see a totally different set of architectures that allow us to take into account physical properties of the real world artifacts and create very intelligent systems. And that will allow us to end-to-end neural network training. That sort of is a overall word view of how intelligence that is being embedded into the real life worlds. With that, I want to thank you for your time and attention. Happy to take any questions and so on. Thank you.
Thank you very much, Rajesh. Fantastic talk. If anyone wants to drop some questions, I know we've only got a few minutes here. Otherwise, we can also take them offline and I can forward them to Rajesh as well. Well, I've got one question. What would you say is sort of the limitations of this technology? Do you think we'll start seeing some ceilings, or in their abilities in the next coming years, or do you think we've got room to run with a lot of these models?
The biggest limitation is the convergence and the friction that appears between technology spaces and human spaces. When humans interact with anything, we anthropomorphize everything. We say, hey, this machine is not working. Why is this machine giving me trouble? And so we sort of humanize everything. And which is why there is so much of consternation on hallucination. It's not that the machine is hallucinating, it's doing exactly what it was designed to do. But how you cannot solve this problem by doing only things within the machines. You also have to change the expectation of humans. It wasn't that long ago that when we saw a printed word, we took it to be true. We today know if it is printed, it is not necessarily true. We will also know very soon if it is a video or audio, doesn't mean it is true. So our expectation has to evolve with that. Our sense of what proprietary, our sense of what machines stand for and how much their role they play has to be rethought. And that adjustment is going to be extraordinarily hard. And it will require our education systems, our technology, to proponents to take into account what used to be traditional liberal arts subjects.
Oh, that's great. That's very interesting. All right. Well, thank you again, Rajesh. Like I said, if you have any questions, feel free to send them in the chat, or send me an email and I can forward them to Rajesh. Thank you very much.
Thank you so much. Appreciate that.
Hi, Abby.
Hey, Scott, how you doing?
Great.
Good. Okay, thanks for inviting me. I'm looking forward to it. So I'm on at 12:05 or 11 your time.
1 second. Yep, I think 11. So I think you should be starting pretty soon here. Let me just chat with Chris. So yeah, so I think we'll start now if that works. So it's with my pleasure to introduce Avi Goldfarb. Avi Goldfarb is the Rotman Chair in Artificial Intelligence and Healthcare and Professor of Marketing at the Rotman School of Management at the University of Toronto. Avi is also the Chief Data Scientist at the Creative Destruction Lab and a Research Associate at the National Bureau of Economic Research.
Thanks, Scott. I need to take over your screen.
Oh, you should be able to just share.
Okay. Yeah, there we go. We're good. Okay. Welcome, everybody, and thank you for inviting me. I'm a professor at the University of Toronto, and several years ago, our administration hired a handful of people doing a technology that didn't seem to really be working, deep learning. And that, we're Toronto, we're a good school, but we're not the MITs and Stanfords, and MIT and Stanford were not hiring these people, and we were. And no one really thought anything of it, and people were doing, some interesting work in our comp sci department. About 10 years ago, this set of technologies turned out to be really, really useful. So that the people who would go on to lead AI research at Facebook, at Apple, and at OpenAI 15 years ago were 2 blocks down the street from me in our computer science department. Eventually, a handful of those people would go on to win. The Turing Award, sort of the Nobel Prize of computer science. And those of you who know how a university works, the way we might normally hear about that is we'd open the email with our university bulletin, and it would say there's really cool stuff happening in the comp sci department. And I'd say, oh, isn't that wonderful? There's great stuff happening in the comp sci department. And then, as a business school professor, I'd go back to my normal day. What's different is my co-authors and I, we run this organization called the Creative Destruction Lab. And the Creative Destruction Lab is a program that helps science-based startups scale. In our first cohort back in 2012, we had another one of those students, one of those people who was sitting in our comp sci department named Abe Heifetz. And Abe said he was using artificial intelligence to discover new pharmaceuticals. The idea was he could predict which molecules bind with which proteins. And using that tool, he could use AI to discover new drugs. Putting yourself back 11 years ago, that just seemed crazy. The idea that you could use artificial intelligence for anything was unheard of. The next year, we saw a couple more companies, another one in drug discovery, and then one in the insurance industry of all places, seemingly using this same technology to try to understand the impact of, to try to use artificial intelligence in business. And over the next couple of years, we had more AI-based startups or more AI startups coming through our lab, as far as we know, than any other program in the world. And at that point, my co-authors and I, who'd made our careers studying the impact of the internet and trying to understand how the internet had impacted business and society, realized that the next big wave was upon us. And so we decided to dig in and try to understand what this technology meant for the world of business. That led to our 2 books, Power and Prediction, most recently, and then our first book, which was Prediction Machines. The underlying, I imagine the reason that Scott invited me to speak to you is this extraordinary excitement and hype around artificial intelligence technologies, especially since ChatGPT was released in November 2023, but even over the years before. But in the last few months, we've had a discussion about a new multi-trillion-dollar industry, that this technology could change computing, culture, and maybe even the course of history. It's suddenly useful when it wasn't useful before, and there is plenty of discussion about whether these are intelligent machines that are going to take over the world. Daniel Kahneman framed this idea that AI is extraordinary by saying clearly AI is going to win, and how people adjust is a fascinating problem. Now, Professor Kahneman is the only psychologist to win the Nobel Prize in economics. And perhaps when you've already won the Nobel Prize, how people adjust is a fascinating problem. But for the rest of us, it's not a fascinating problem, it's a terrifying problem. If the machine's intelligent, what does that really mean for us? Where do we, what does our future look like when faced and competing with intelligent machines? Underlying both the hype and the anxiety is this question about what we mean in 2023 when we're talking about artificial intelligence. If you believe the press, it feels like Skynet is right around the corner and the Terminator or the Matrix are imminent. Well, I don't have much of a thesis on what exactly it means to be in a world where the Terminator and the Matrix are imminent. But I do know that the current large language models and other AIs that are generating all this excitement have very little to do, in a straight sense, with artificial general intelligence. What they are prediction technologies, in the sense of using information you have to generate information you don't have. It's prediction, machine prediction, that's gotten much better, faster, and cheaper. And in our first book, Prediction Machines, we frame that as a drop in the cost of prediction. Now, yes, Econ 101, if you're taking a micro class, Econ 101, the very first thing you learn is the demand curve slope downward. And so that if something gets cheap, you're going to do more of it. When coffee gets cheap, you buy more coffee. When prediction gets cheap, when machine prediction gets cheaper, we're going to see more and more machine prediction. First order point here is this is not artificial general intelligence like you see in science fiction. It's a prediction machine. It's computational stats. Had we called the book The Simple Economics of Computational Stats, I think fewer people would have bought it. But the framing of thinking about it as artificial intelligence is useful in many ways, but it's misleading when thinking through what the technology really does. So as prediction's getting cheaper, we're starting to use prediction machines in more places. The first applications are good old-fashioned prediction problems. Like you walk into a bank and you want a loan, and it's maybe the oldest prediction problem in business to predict whether they're going to pay back that loan. Increasingly, we're using AI, we're using prediction machines to figure out machine learning to figure out whether they're going to pay back their loan. The insurance industry, they're in the business of pricing risk. That's what they do. They're in the business of prediction. And increasingly for their underwriting, they're also using these machine learning tools. They're also using prediction machines to help support those risk, their predictions about whether you're going to make a claim. Interestingly and importantly, as machine prediction's getting cheaper, we're starting to realize that some things that we didn't used to think of as prediction problems are now solvable with machine prediction. How does Google recognize an image of a cat on YouTube? Well, it takes in these the pixels, the location of them, and on the X and Y axis and their color, and it fills in the missing information of a label in a context. In fact, that's exactly what your eyes do, what you do when you recognize a familiar image or a familiar face. You take in these light signals and you fill in the missing information of a label in a context. But that's now only technically feasible because machine prediction has gotten cheaper. And medical diagnosis is prediction. What does your doctor do when they diagnose you? They take in information, data about your symptoms, and they fill in the missing information of the cause of those symptoms. So point number one is today's AI is prediction technology. And that is even true of these amazing tools we've seen from OpenAI and others, these generative models. The large language models are predicting which sequence of words you're looking for in response to a query. They're predicting which words go together well if you ask a question like, how will AI affect productivity and inequality? The image generation tools like DALL-E and Stable Diffusion and others, are again predicting what you want in response to a query. If you ask for an image of an astronaut on a horse in the style of Andy Warhol, it's not a search engine. It's not finding that image in its database and giving it to you. Instead, it's predicting what you mean when you're asking for an astronaut on a horse in the style of Andy Warhol, using its data on people on horses, images of that, astronauts, images of that, and the style of Andy Warhol. And it's a prediction of the combination that gives you images like this. As we've seen prediction machines, AI, in more and more parts of the economy, Andrew Ng's idea that the AI is the new electricity has permeated the conversation in various ways. What does that mean for AI to be the new electricity? Well, if we think about it, electricity, it's transformed the way we live and the way we work. And so AI has this potential to transform the way we live and work and allow organizations to do things differently. In prediction machines, we talked about what that might mean and how that might play out. Imagine you have a dial and you're turning the dial on those predictions and making them better and better and better and better, all the way to 11. Well, here's a prediction you guys should be familiar with. These are Amazon's predictions about what you might buy. Their predictions are incredible in the sense that they have hundreds of millions of items in their catalog, and they predict accurately about 1 out of every 20 times. So for every 20 items they recommend, you buy one of them, 5% accurate. So it's an extraordinary prediction, technical feat. But it hasn't really transformed the workflow and the process for you buying from Amazon. Amazon was a catalog company in 1995, and it is still a catalog company. 20 years ago or so, if you wanted to buy something on Amazon, you'd go to their online catalog. They would recommend to you something, but that recommendation wouldn't be an AI. They would just say, buy the Da Vinci Code. That was the most popular item, and everybody pretty much got that recommendation. You look for the Da Vinci Code, you say, yes, I want that. They send that information to the warehouse, and they ship it to your door. Fundamentally, that is still how it operates from the customer point of view, right? You have their online catalog, they make a recommendation. You may or may not respond to that recommendation. Whatever you decide on, they send it to the warehouse, they ship it to your door. Now, imagine that Amazon could do things differently, that they could build a prediction machine that wasn't just 5% accurate, 1 out of 20, but 20% accurate, or 50% accurate, or 70% accurate, or maybe even more. At some point, their predictions are going to be good enough that they're not going to wait for you to order. At some point, rather than having you shop and then they ship it to you, they'll ship things that they think you want to your door, and then you can open the box at your door, choose what you want, and leave what you don't. Rather than shopping then shipping, it will flip to shipping then shopping. Now, I don't know if Amazon is actually going to implement this. There are all sorts of challenges associated with it, but they have thought about it. Here's a patent for anticipatory package shipping from Amazon. But if you look closer, something's off. This patent is from 10 years ago. Amazon has been thinking about shipping things to your door before you order it for 10 years. And still, it hasn't happened. How does that make sense? Even beyond Amazon, many, many companies who've invested in AI still haven't seen the payoff. How can we reconcile those challenges with this idea that AI is the new electricity? Well, once you dig into the process through which electricity changed the way we live and work, you can understand what it means for AI to be the new electricity and why the payoff for so many companies hasn't happened yet. Edison's patent for the electric light bulb was in 1880. Tesla's patent for the AC electric motor, 1890. If you were paying attention in the 1880s, it was clear that electricity was going to transform the way we lived and the way we worked. But it wasn't until the 1920s, 40 years later, that the median household and the median factory were electrified. How did it take 40 years from understanding the potential of the technology, seeing that it could transform the way we live and work, till it actually impacted most Americans at home and at work? Well, that wandering, those 40 years, had to do with figuring out how to use the technology to do things differently. This is what a factory might have looked like in the 1880s. You can see there's a steam engine at the center of the factory. And every single machine in the factory is connected by these belts to the steam engine in the center of the factory. And if you remember your high school physics, may or may not, energy dissipates with distance. And what that means is, in designing your factory, you want to put the most power-hungry machines as close as possible to the power source. And so the logic of the factory was determined by the power needs of the machines, with the most power-hungry machines in one place and the less power-hungry machines farther away. And the workflow went back and forth from the power-hungry to the less power-hungry machines. That meant, because it was a back and forth and not logical, you wanted to move things as few times as possible. There wasn't a natural workflow based on what you wanted to do. The workflow of the factory was determined by the power needs of the machines. Some entrepreneurs and factory owners realized that electricity had just come along and it was cheap power. And they could do things cheaper. It could save 5, 10, maybe even 15% on their energy costs. And that handful of forward-looking entrepreneurs and managers did replace the steam engine, dropped in an electric motor at the exact same point, and left everything the same. In the process, they saved 5, 10, 15% on their energy costs. But for the vast majority of factories, that's not enough. For the vast majority of factory owners, it's not worth it to take out your steam engine, drop in the electric motor, figure out how to get electricity into the factory, figure out how to deal with fire safety, where to put the wires and all these things. It just wasn't worth the bother. And so they didn't. And by 1900, we only had something like 5% of factories electrified. But then people started to realize that electricity was not just cheap power. Electricity was distributed power. And distributed power allowed you to decouple the power source from the machines, so that in a second wave of electrification, people realized they could design an entirely new kind of factory. The Henry Ford style factory with inputs in one end and outputs out the other, that was a direct consequence of this decoupling of the power source from the machines that electricity enabled. That led to a second wave and a rapid increase in the adoption of electricity in factories. For AI, we're in the 1890s. We can see the potential of the technology, but we have not yet experienced that transformation. Maybe it's starting over the past few months with ChatGPT and other generative models, but we haven't quite figured out, what does the organization of the future look like? What can we do better? What can we do differently now that we have much, much better prediction tools? And the vast majority of the AIs and the deployment of AIs that we've seen thus far are point solutions. They're like that process of taking out the steam engine, dropping in the electric motor in the exact same spot, and not messing with the workflow. And because we're not messing with the workflow, the upside potential of these technologies is limited to the savings in that particular part of the workflow that a company can get. And that's how we start to understand why so many adopters of AI haven't seen the benefit. They're looking for easy wins, doing what they always did, but a little bit better, because messing with the workflow is hard. But the big upside opportunity is when you think about system level change, developing new ways of doing business, rather than taking out your old a task in your old process, dropping in the new machine, and keep everything else in the workflow the same. Now, AI has potential to be disruptive. How is it? How do we think about that organization of the future What might it look like? And what might the challenges be in deploying it in established organizations? So I told you about this, the Creative Destruction Lab, this program we run for science-based startups. And it's a mentorship-based program. And so the founders come in and they often talk about what they're doing, their AI. And the mentor, one of our mentors might ask them, so what's your AI for? And many of the founders, especially the ones who are just coming out of comp sci departments or on the highly technical side, they say, you know, our AI is fantastic. It's going to build amazing predictions that will provide our new customers with insights into how the world works. At that point, you can see the body language and all the mentors just collapse. If somebody says their predictions, their AI is for insights, that's code for I have no idea what my prediction is for. Insights is a word that tells us that people have no idea what they're going to do, because prediction is valuable for one reason and one reason only. Prediction is valuable because it's an input into decision making. In the absence of a decision, a prediction is useless. If someone says insights, it means they don't know what decision their AI is going to feed. And it's decision making that's everywhere. Decision making is a big deal. You make decisions. All the organizations are effectively decision engines. But prediction is not decision making. And as the machine gets better and better at prediction, other aspects of decision making become also more important. Right now, when you make a decision, there is a prediction and a judgment that go together in your head. The judgment is effectively knowing which predictions to make and what to do with those predictions once you have them. What AI does is it does, and that decouples the machine prediction from the human judgment. That is difficult and challenging and creates the opportunity for doing things differently. To understand what I mean by the AI does the prediction and the human does the judgment, I want to go back to science fiction. I'm not sure if you've seen this movie, I, Robot. It's a solid movie, but it's excellent science fiction. Here's why it's excellent science fiction. So Will Smith is the protagonist in I, Robot, and he hates robots. And it's pretty clear, you know, how the movie is going to go because of that. But the reason he hates robots is described in a flashback scene. He and this little girl get into a car accident, and they both start sinking into a river, and it's pretty clear they're both about to drown. Then a robot comes along and saves him, and not the girl. And that's why he hates robots. Because it was a machine, he could audit it. And he figured that the robot predicted he had a 45% chance of survival. And the girl only had an 11% chance of survival. And that's why the machine saved him and not the girl, because 45, his chance of survival is more than 11, hers. And he says, but 11% was more than enough. And a human being would have known that. Well, that's a statement about judgment, the relative value of those lives. That remains, even in a world of autonomous robots and prediction machines, a human decision. It remains a judgment call on the part of the engineer or team of engineers who design the machines, what we value, what matters, what's the machine trying to accomplish. That's what we mean by this decoupling of prediction and judgment. So there's not such thing as a machine decision, but machines can change who makes decisions. And that's what makes this decoupling so disruptive. There's been some stories lately about AIs potentially picking who gets hired and who gets fired. Some of these are, are exaggerated, but nevertheless, imagine that what they describe is true. Imagine that you have workers in a warehouse or a store or a call center, and at the end of every day, they get an email that said that based on their performance during the day or over the past week or more, says you get to keep your job or you're fired. The narrative is that's an AI making the decision, but that's wrong. What's actually happening is that there is a team of HR professionals or others at headquarters. That team is deciding what score should determine success in the organization, what score measures success for those employees. And then that team also determines a threshold above which or below which the person gets to keep or lose their job. And that person gets to decide, that team of people get to decide whether to deploy that AI in the first place, whether to deploy that prediction engine in the first place. And they do that, and it deploys, and people say, oh, that's not fair. There's a machine deciding on things. There's no machine deciding. The decision maker, the team or decision makers, is the team sitting at headquarters that built that AI. That's the key message to understand. It's not, machines don't decide, humans do, but machines enable a change of which humans get to make decisions. Instead of managers on the ground in each warehouse or each store, we now have a massive centralization of power within the organization so that a team at headquarters can decide what it means for their workers to succeed or fail. This decoupling is disruptive, and this can change who has power over the decision. The last thing to think about as you move forward is, well, should you worry? How does this affect your job? How does this affect the organization you're part of, your students, your mentors, your family, and others? A lot of this depends on how good a job you do at serving the key stakeholders for your organization. What do I mean by that? This is, by many accounts, the best airport in the world. It's Seoul Incheon Airport. What it and Singapore, the other that are often listed as the best in the world have in common are fantastic natural light, great shopping, restaurants, and then they have their own idiosyncratic features like a theater or waterfall, great greenery, a greenhouse, fantastic hotels, all sorts of other things. These are beautiful, multi-billion-dollar structures, architectures. But if I asked you whether you'd rather fly through this beautiful multi-billion-dollar structure or this much smaller, much cheaper, much simpler airport, the vast majority of you would say you prefer this one. This is how the super rich fly. If you're flying private, you fly through a private terminal. This is the private terminal, I'm told, at Boston Logan Airport. That looks like this. There's a couple of chairs, maybe a plant. It's pretty ugly. There's a magazine rack, but if you look carefully, it looks like it's the same magazine over and over and over again. This is how the super rich fly. How does that make sense that those of us who can't afford it fly in these beautiful multi-billion-dollar structures? And the people who are paying many times what we are to fly through these things that basically look like little sheds. Well, what's the mission? What's an airport trying to accomplish? Even Seoul Incheon, their mission is to ensure smooth air transportation. And almost all of those billions of dollars are dedicated to that they fail to ensure smooth air transportation. Smooth air transportation means you walk right on the plane. You don't need shopping. You don't need restaurants. You don't need theater. You don't need natural light because you don't spend any time at the airport. It's only when we fail to deliver on our mission because people don't know how long it's going to take to get to the airport through security into the gate, and that there's all sorts of delays as well. It's only because we have bad prediction in this particular industry, and we fail to know when we're going to get to the plane, that we end up with these multi-billion-dollar structures. Airports aren't the only industry that we fail to serve our customers. Now imagine that you go to your doctor and your doctor looks at your blood work, family history, other information, and says, sorry, but there's a a 5% chance something catastrophic is going to happen to your health over the next year. But don't worry. If that happens, we will write you a check for $500,000. You'd be, that's not okay. That's not how medicine's supposed to work, right? What your doctor is supposed to do is provide that prediction of whether something's going to go wrong, and then provide a treatment plan to help you reduce the risk that that catastrophic thing happens to your health. Luckily, for the most part, that's not how medicine works, but it is how home insurance works. Your insurance company takes in all sorts of data about your house. And in today's world, they could have satellite imagery data and home inspection data and pictures of all sorts of parts of your house. And they compile all that data to make a prediction about whether something catastrophic is going to happen to your house over the next year. And with that information, then they then price it to say, well, we know that your house has a really good chance of leaky pipes. And so your insurance is going to be more expensive. But don't worry, we're going to provide you with peace of mind against catastrophic loss, because if that happens, we'll write you a check. But that's not peace of mind against catastrophic loss, right? Peace of mind would be, well, we know that it's water non-weather, that there's a chance that your house, the reason your insurance is so expensive is because there's a good chance of leaky pipes. And we can provide you with a sensor that you can put into the water, into the pipes in your home that will turn off the water if we detect a leak before catastrophe happens. We will provide a treatment plan rather than just write you a check. Now, that treatment plan is doable. And the hard part in the insurance industry is not the prediction. Those predictions about which houses have higher risk of certain items, water, like leaky pipes, electrical fire, etc., that's doable. But we've been working with an insurance company, and it's very hard to make it all happen. We're getting there. But there were all these sources of resistance. First, the data were controlled by underwriting, and underwriting was the power source, power center in the insurance company. But what we're describing isn't about underwriting. It's not about predicting risk. It's about changing behavior. And the center for changing behavior is marketing. Risk reduction, not just risk pricing, requires behavior change, which requires marketing. But the marketing people in the insurance company never really had access to the great data. And underwriting wasn't that willing to give up their access. And the marketing people in many insurance companies aren't the best marketing people in the world, because that hasn't really been fundamental to how to, to the profit centers of the insurance company. That's always been underwriting. Eventually, we got marketing and underwriting to agree with each other. Underwriting agreed to share data. They all got that up and running. And we hit another problem, which is that this marketing part of the organization wasn't called marketing. It was called marketing and sales. And the salespeople were compensated by commission. And they didn't want to provide a product that was going to reduce prices, even if it increased profitability and served consumers, because it was the direct reduction in their core compensation, which is commission based on revenue. Now, all of that suggests that these power changes, this ability of AI to help you make better decisions and change power, can be complicated even once you figured out how to use AI to overcome the challenges where your organization fails to deliver on its mission. Underlying these between times is we are all figuring out how to get from the organization of the past to that organization of the future that takes advantage of this decoupling of prediction from judgment and creates new opportunities. Thank you very much. We've got some time for questions.
All right. Well, thank you very much, Avi. That was a fantastic talk. So if you have any questions for Avi, feel free to add that into the Q&A. I do have a couple, so we can just kind of start that way. So as you'd mentioned, there is sort of a long time for the uptake of these systems, or the kind of the to capture the value of these systems and organizations. What do you think the future landscape might look like? Do you think established organizations will be able to make these systematic changes? Or do you think there's going to be a major transfer of value to upstarts or startups that are reimagining some of these, traditional value chains?
Both. I think this is a great time to be a startup because there is a whole industry that's been opened up and there's new ways to unlock value, and the entrenched interests of many of the largest companies won't know how to, those power challenges within the company that I just described in terms of the insurance industry, they're going to make it difficult for many established companies to respond. At the same time, in many contexts, the established companies are going to have really useful assets that are complements to what prediction can do, as long as they can figure out how to reorganize. And so, we're already seeing the established tech companies taking advantage of AI and doing well.
Right.
There's lots of examples in the banking industry of banks being able to do things that they had already done, but better with AI, with some reorganization and imagining new ways to deliver value. So I think there's the losers here. There's a third category of winners, which are companies that sell complements to AI can do some amazing things. And so, if you're a pharmaceutical company, you don't have to be an AI company. But if AI is leading to better diagnosis, then there's going to be opportunities for new kinds of treatments and new kinds of drugs. And so a benefit to innovation in pharmaceuticals that has nothing to do with AI per se, but is a complement to AI. The people who are going to lose are the people who sort of put their head in the sand and just think they can do what they always did without changing things.
Okay. It looks like we just got a new question. So do you think capitalism is still a viable system when a significant number of jobs can be replaced by advanced AI and robotics? Surely not everyone can have a job as a decision maker using insights from AI.
So yes, I 100% think the system we have, let's call it democratic capitalism, has a future. Now there's a whole bunch of economic ideas underlying that faith. Okay. And economic idea number one is something that William Baumol, that's called the Baumel's cost disease. And that idea is that as certain parts of the economy get more and more productive, they actually become less important to the economy. And our jobs, our income ends up going into essentially the parts of the economy that don't grow. So agriculture, I think most of our great grandparents worked in agriculture. Now that's no longer the case. Agriculture has gotten much, much more productive, but it doesn't need as many humans. And so in the late 19th century, as agriculture got more productive, which is actually manufacturing that wasn't so productive, and more people went into manufacturing. Then starting in the middle of the 20th century, manufacturing started to get really, really productive. And we had fewer and fewer people over the next 70 years working in manufacturing, but we didn't have much progress in services. And so we've had more and more employment in services overall, because that's actually the part of the economy that didn't get more productive. Now, I don't think we're on the cusp of AIs being able to do everything. And as long as there are some things that humans can do that are valued, then more and more of us are going to have those kinds of jobs. So point number one is Baumel's cost disease. Point number two is not everything, there's lots of value in judgment, right? For sure. So humans are going to be doing judgment. But there's also other tasks or other aspects of decision-making that we humans are good at that for now, the machines aren't. So there's a lot of actions that that benefit from having a human. At the extreme, professional sports, watching robots compete against robots, that's not as interesting as watching humans. There's still an interest in professional chess, even though humans machines can definitely beat the humans. And
Mhm.
so that's to the extreme, but there's a lot of actions that are a long way from that
Mhm.
still require a human. Caregiving related actions, certain kinds of medical treatments, etc. So that's like we're a long way away, in my view, from AIs being able to take over all the jobs
Mhm.
and all the tasks in a workflow. And so combine that with Baumol's cost disease, there's still plenty of humans to do. And I actually released a piece Brookings on Monday
Mm.
that takes a lot of the discussion about AI has been quite pessimistic with respect to jobs and inequality. And I think there's reasons to be optimistic about AI and jobs, particularly with respect to inequality, because a lot of the things that large language models and other machine predictions are doing are the things that people at the top of the income distribution do.
Mhm.
So over the past 40 to 50 years, we've had an increase in inequality. There's been two sources of that increase in inequality. First one is the capital labor share that the people who own the machines have done better and better. And that's, that is, I think the future is going to be like the past on that one. But the
Mhm.
second one is different. The second one, with computers and the internet, they augmented the skills of the people at the top of the income distribution. People who are good abstract thinkers did better and better and better with computing and the internet, and everybody else did the same,
Mm.
a little bit better. A lot of the things that AI does well are the things that people in the 80th and 90th percentile of the income distribution do well, whether it's medical diagnosis or writing elegant prose or designing beautiful images. This is knowledge work.
Yeah.
And there's a negative side to that the people in that work are going to be worse off. But there's a flip side to it, which is millions of people's job prospects are constrained by for example, their ability to write well in English. And they're going to be empowered by having these tools to do all sorts of things and take actions that they were unable to take before. So there's this, one last point in this. There's this story, it may have been, it's a useful parable if it's not a true story, on Twitter, with this guy who was a great landscaper, a great gardener, but he was a terrible writer, and he couldn't write a note to his potential clients or his clients just saying something as simple as, hello, I'm going to be there on Monday, 9 a.m. And he had a neighbor or a mentor or somebody integrate his email system with GPT-3 that enabled him to write elegant emails. And once he could write elegant emails, he was able to his business was able to grow because he was a great, according to the story, he was a great gardener. He just didn't know how to write. And you know what? Who cares if your gardener knows how to write? That was an artificial constraint. And I think there's millions of people who have this ability to be empowered by what these tools can offer.
Fantastic. Yeah. I know I definitely have used it for, crafting emails and things like that. So it's been helpful in that respect. But so do you think as well, are we on the cusp of, AGI or some sort of general intelligence, or do you think that that's going to be something that's, a little bit farther off in the distance from?
I have no idea. So we've been hearing since the 1960s, the leading computer scientists have said, we can see the path to AGI, and they have artificial general intelligence, and they've said that's 20 to 50 years away. Until 6 months ago, that was still the consensus, 20 to 50 years. In the last 6 months, the consensus has moved to 10 to 40 years.
Okay.
Now, maybe, and I'm actually glad there's really smart people thinking about these issues, but that is not, we think about what does ChatGPT mean for jobs in the economy, and inequality and liberty and democracy and all that. I think the AGI discussion is a distraction from a number of more meaningful discussions.
Oh, that's, oh,
We got another question.
okay, here, yep, got another question. As learning models grow more sophisticated and harder to dissect, do you see AI taking on both the prediction and decision-making roles? What sort of disruptive effects might we see as decisions and management practices are radically redesigned in a new Ford factory model? This is from James.
Okay, so James, two great questions. So on the first one, what's happening is the human decision, the judgment, is moving effectively up the stack. And so in the original way, often we thought about a prediction machine is the machine would provide a prediction, and for every single decision, you need a human in the loop to decide what to do. Okay, so, you know, hey, we get, 75% chance of this, then a human decides. So if you think about Google's blue links, there's a prediction, here's the things you might want based on some probabilities that Google knows, and they rank them, and then you make a decision about which one you want. Okay. Now, we can move that decision up the stack where you're feeling lucky, and they just, you know, with say Siri or a voice model, they only provide one response. But what's happening there is there's still an engineer at Google who's deciding, or a team of engineers, presumably, what decision to make based on the underlying predictions. And so there is a limit to that. And so there is still, in a world of prediction machines, there is ultimately always a role for decision making. But as the predictions get more powerful, what it enables potentially is a centralization of power. And a smaller number of people are going to be able to control a larger number of decisions. And then your second question, you know, what are those disruptive effects? I have lots of hypotheses, industry by industry. But ultimately, the point of the between times is we don't know until people run these experiments and figure it out. I'm confident in saying a lot of the power, a lot of that change is going to be through this decoupling of prediction for the rest of the decision, which enables new people, sometimes a centralization of power, sometimes decentralization, but a different set of people to do things that they for. And I should say, for the longer answer, like in the book, we have chapters about this, but I don't think I can do that in the 3 minutes allocated.
So one more, so Hement is asking, so other than judgment, humans also have empathy. Could you talk about maybe how empathy might fit into your thoughts?
Sure. So empathy is the ability to understand the perspective of others.
Mm-hmm.
And it's an open question whether that's something that machines can have. It's not an open question. Lots of animals also have empathy. Machines seem to be able to put themselves, give themselves the perspective of others if you ask. But it's just sort of a philosophical and psychological question about whether that's empathy and not my expertise. Okay.
Mm-hmm.
In terms of the way we're thinking about this, so this is very much a decision theoretic framework on prediction and judgment and actions. And in a decision theoretic framework, we think about judgment. These are the payoffs at the end of the decision tree. And empathy is going to be an input into those payoffs. So you might think of it as a utility function. You might think about it as payoffs, profit payoffs, or some other payoffs. But it's what you value. And empathy is going to be one of the core inputs into what you value. There's going to be other inputs into judgment as well, but empathy is going to be very much a big one. Great question. Okay.
All right. Well, I think that just about covers it. Well, thank you again, Avi. This was a fantastic talk, and thank you for your responses to all the questions. And if you've got any other questions or anything like that, feel free to send them to me, and maybe I can follow up with Avi later on. But thank you very much, and we'll be having our disruptive innovation in our own backyard panel in the next 10 minutes or so.
Okay, and we just got a new question: quantum computing and AI. Just as a quick.
Okay, yeah, maybe. Quick
quantum computing is fascinating. I've done some work on that recently. It's not obvious that there's any, in terms of AI, that it's anything more than what we've always done, but potentially a little bit better. If you're interested, you can look, Avi Goldfarb Quantum, you can see I have a slow management review that came out recently. Take care.
All right, thank you.
Bye.
Hi, Ross.
Hey Scott, how's it going?
Good, good.
I was a little nervous, and I'm sure you were. I was actually in the meeting that I apparently created for myself as a reminder, and I'm like, where is everybody?
Oh, no. Well, I'm glad you're here.
Yeah. So this is a full day thing you guys got going on.
Just a half day or so from 9 to we're gonna do from 9 to 1. So this is kind of the last little bit here. So
Cool.
all right. Well, looks like we've got looks like we're waiting on Deepak here.
I'm here. You hear me?
Oh, okay.
Hey, I've been here.
Okay, great. All right. Well, so to begin this panel, so disruptive innovation, a concept originally articulated by the late renowned scholar Clayton Christensen, refers to pioneering advancements that redefine established norms within any given industry. While the narrative often gravitates towards the astounding triumphs of startups located in coastal regions, Southeast Wisconsin's contributions frequently remain unsung. In an effort to bring attention to this, our panel has been thoughtfully composed of experts hailing from three distinct sectors: healthcare, 3D imaging, and manufacturing. Each panelist will bring to the table some unique insights from their personal journeys with innovation. So with that, let's start with some brief introductions. Ross, if you want to kind of tell me a little bit about your background, your role, and describe your company.
Yes, absolutely. Thank you, Scott. I am an entrepreneur that has really embraced that in the last 3 or 4 years. I got my undergrad at UWM in business, and then just finished up my MBA with an emphasis in entrepreneurship. And prior to the pandemic, I actually started my first startup, which was a food tour company in Milwaukee. It was called Secret Food Tours. It was very unique. It was a secret agent themed. I wore a little Secret Service earpiece, brought people on a little spy adventure, ended up at the safe house. But during the pandemic, obviously that had to shut down. And so that was really my first experience in having to embrace a whole new way of looking at how I could bring that potential product to the masses. That got me to look into virtual tours, 360 photography, 360 video, even getting into virtual reality. And so I started a small company that specialized in that, and also updating Google Maps and Google Street View for businesses. And through UW Milwaukee, through the connections with some of the business plan competitions that the university offers, I was linked up with a startup called Tech Render, which is a Milwaukee-based company that does building documentation for architects. And so in that role, we really embraced the idea of disrupting what would be the typical workflow for renovating and refurbishing an existing space. And I can go more into detail. I'm not sure if this is the appropriate time, or you just wanted my.
Yeah. I'll ask some more probing questions about those things. But yeah, that's fantastic, Ross. Thanks. And Kyle, I guess we'll just kind of go around the.
Sure. I'm assuming you can hear me and see me?
Yep.
Great. I'm just looking at this picture, realizing how much of a baby I was when I took that. Kyle Crum, I'm the Director of Advanced Technology here at Rockwell Automation. I also run the Global Product Standards and Regulations organization, which is all about technology, really adoption and dissemination. My background was nuclear. I was a naval nuclear propulsion designer. Then I actually served in uniform for 8 years in the Navy. Also primary metals with Alcoa. They became Arconic. And now I run the technology organization here. My background's primarily, though, managing research teams, right? Product development and research. Rockwell Automation is a multinational automation company. Anything you need to make a thing. So we don't make the thing, nor do we typically make the machine that makes the thing, but anything that you need to make the machine that makes the thing, literally anything. We'll even sell you the pin with a Rockwell Automation name on it, so you can write on the little cards on the automation machine. So my research group has to cover everything from augmented reality to motor design and control theory, cloud to embedded. We just cover a massive scale. So that's me in a nutshell.
Great.
Thanks, Kyle and Ross, and thanks, Dr. Scott, for giving the opportunity today. My name is Deepak Arora, and you can see I'm the founder and CEO of Wearable Technologies. You guys can hear me okay, right?
Yep.
Yeah, okay. I'm also, like Ross, a recent MBA grad from Lubar School of Business from UWM, with emphasis on the healthcare leadership. And background-wise, I'm an electronics engineer and computer science professional. I have over about 20 years experience now, 24 to be accurate. Worked in different financial domain, banking domain, all the way to entertainment, similar to Netflix. Then moved into the medical side of the world, working at IBM Watson Medical Imaging for over 8 years. And during that time with IBM, I also became an entrepreneur and started my own AI startup. So we're 2 years now, just around 3 years total. The startup is a completely disruptive, innovative technology that we'll talk more about, I'm pretty sure. It's an AI startup, which is geared towards not just detecting hazards or preventable accidents, but being able to predict those accidents as they happen or before they happen, and then provide protection with a rapid response mechanism.
Mhm.
So that's in a nutshell about me.
Great. My first question for the panel is, so how is your organization distinguishing its approach or strategy from that of your competitors? So what is really disruptive, or something that you're pursuing that's disruptive at your organization? And, how are these things kind of, setting yourself apart from other kind of folks within your industry?
Because I was the last, so I can go first this time.
Okay, sure.
So the biggest approach that we are coming up with in the space of your personal safety is being able to, like I said, not just detect those incidents. That's where most of our competitors and other folks are who have the similar technology out there. So when I talk about preventable accidents, the preventable accidents such as your drowning incidents, falling, extreme temperature conditions, hypothermia type situations, where most of the technologies can only detect as it's happening, or it has happened already. So more like reactive approach. But with the onset of AI, machine learning, we had a talk with Dr. Rajesh just a couple hours ago about embedded learning. That's where we are bringing that technology at the edge. So you can see, so edge computing is where we can learn those patterns over time. And none of our competitors have that capabilities today.
Mm-hmm.
And that keeps us disruptive in that space.
Okay, interesting.
I guess since I went middle, I'll go middle again. The hardest thing we're doing is the convergence of IT concepts with operational technology, with OT. So operational technology like PLCs and devices on the factory floor are designed to be deterministic. They're designed with 30 years in a dusty, dirty environment. If they operate incorrectly, people can get hurt.
Mm-hmm.
So there's this fusion of how do we take agile concepts and get out there and try really quickly, etc.
Mm-hmm.
How do you do that in an environment that's not a cyber environment, it's a cyber physical environment? And I'm really proud of how we're doing that, where we're maintaining all of the requirements to be that are expected of us, right? Longevity and this really high integrity. But we're bringing in $1 trillion worth of innovation in the IT space. How do you fuse those tools into it? And so our systems are evolving very rapidly, but with all of those things that the IT world doesn't necessarily have to think about, right? If my computer misbehaves, I reboot it, right? AI has to be deterministic, right? How do I apply AI in a way that's functionally safe and I can statistically prove that? And So those are all key challenges and areas of deep innovation.
All right, and I just let there be a pause because I will by default jump on every question. So I'm glad that we let it settle a little bit here. But I think that, so, at the core of what we're doing, we are really working in the metaverse, which is taking the real world and making a digital counterpart. And so instead of going out with a laser measure or with a tape measure, heaven forbid, at our core at Tech Render, what we're doing is we're taking LiDAR scanners, which is laser distance and ranging. We're getting millions and millions of XYZ coordinates and building really robust data sets that are highly accurate that you can then use to design around, use to verify construction. And that's something, the tool set is something that is being utilized in many industries. But I think that where we're unique is we have one of a service-based approach. So as opposed to trying to sell folks the scanner or the drones, scanners can run $60,000 plus. Drones, can become very costly, especially if you crash them, which is kind of a rite of passage as a drone pilot. And so we really want to provide that service first and foremost, make it more accessible, and really plug into the virtual design construction process wherever either an architect or an engineer or a construction company may have some type of deficit. I think that though where we are also innovating is in combining those different technologies. And so, for instance, terrestrial laser scanners, generally it's something that, that you capture from the ground, which is great, but then you can't get roofs that well. There's going to be gaps in your data. And so you can capture that with drone imagery, but usually those are two completely separate data sets. And so where we're innovating is we're finding kind of the common denominator between those two and seeing where we can overlap those data sets to provide a more comprehensive picture, but also, provide, have some degree of being able to measure that accuracy and that confidence. And then in other ways, we're also looking to just continually improve that process and speed it up. One thing that I've learned in our space is that there is such thing as too much data. You'd think that you just want to crank that baby up to 11. You want to get as much data as humanly possible, but sometimes you don't need that. Sometimes you just quickly need to know what the exact room dimensions are. You need an as-built floor plan as a building is today. And so actually by collecting less data, you can maybe take scans from 1.5 minutes down to 15, 20 seconds, expedite that process and provide more value to the customer. So yeah, I would say those are the two main areas that we're really innovating.
That's fantastic. So my follow-up question is, how has the region, kind of played a part in your success? I know many of you kind of talked about your ties to UWM. Are there, certain things that are unique about Southeast Wisconsin that has helped you?
Absolutely. I'll go first on this one. We're one of the founding members, or we're the founding member of the Connected Systems Institute at UWM, which I would invite everyone on the call to join, because it's not Rockwell's institute, it's UWM's institute, but we wanted a Connected Systems Institute focused here in the region. Obviously, we're academics, right? We are the bridge between academia and other industries and the corporate world. So having such high caliber academic institutions in the city is imperative. And I'm not just talking about the technical sides of it. Our information sciences, like library sciences, are absolutely critical. Psychology, even the arts coming out of these institutions is absolutely imperative. When engineers make a UI, it's gray, it's square, it's really annoying and boring. But when you get somebody that has a creative mind, we've absolutely hired literally people with art degrees to engage, because human machine interaction is changing rapidly. So I know this is obviously hosted at UWM, but I'm not just speaking to the local, to the audience here, but Having institutions of such high caliber in the city allows me to recruit. It allows me to collaborate, grow the employee by letting them audit a class. It's central to our success. A healthy, vibrant academic, series of institutions.
Yeah, I would say that really what's unique is that I know that everybody thinks about innovation being on the coast, and that is true, but that also has an impact on the adoption of different technologies. And I think that where we're uniquely situated, and you can almost draw a line, you see that in architecture, for instance, there is slowly becoming more adoption of more advanced modeling techniques. So CAD is the default, which is generally more of a 2D based line work, whereas now the industry is going to Revit. And it's something that there is slower adoption in southern Wisconsin than perhaps in the Chicago market. And then as you go up to Green Bay, as you go up to Wausau, it's even a little bit slower behind that. And that also means that the data set that you need is unique. And so I think that that's where we have really positioned ourselves well, that we can have the added benefit of looking to other organizations that or other areas of the country that maybe are a year or two ahead from the adoption standpoint, kind of learn from their mistakes and really expedite and become more efficient with what we're providing. So I think that that is something that is very unique. And also, it just seems like it's Milwaukee in general. It's a big city. You have all the amenities of a big city, but you have the charm of a small town. And I think that that's really key as well. That there's so many different people that you can interact with, that you can network with, but also it's not so saturated that you are only interacting within your tight niche. It's something that, if you're going to an industry event, instead of having 500 people and you get to know the people in your breakout, it's something you might only have 80, 90 people, but they're across all different areas of the industry. And so I think that that's where you can really start making connections, and you can see, okay, where's augmented reality? How could this, there's unique display technologies. How could this work? How can you capture things differently? And that's what's really neat, is that I think that you get all of the benefits, but it really facilitates more discussion being kind of in one of these mid-sized markets.
Great, that's awesome.
Thanks. I think for us, it's been completely monumental. And I'll talk a little bit about my background. I've lived in bigger cities, bigger countries, moved from India to Toronto, Canada, and then all the way now to Wisconsin. So I've seen what a big fish can be in a big pond versus a big fish in a small pond. That's where I think what Ross was saying earlier about the feel of the local city vibe within Milwaukee, even though it's big with all the amenities around, you still get that focused approach being local here in this region. For example, for us, the biggest issue was funding. Obviously, Wisconsin is not known for a big round of fundings that can happen, but we were able to make that happen locally, all of it. We haven't gone out for funding at all. Huge compared to 5 years ago, even I wouldn't say just before pandemic. I had a friend who had a startup and didn't go that well because he ran out of funding pretty soon. And it was hard to go out and look for funding, staying within Wisconsin. So that's been definitely monumental for us. And then having LUBAR Entrepreneurship Center built right here in our backyard, so to speak, and they have this absolute amazing program called I-Corp, Intelligent Corp, Innovation Corp, sorry. And that definitely helped us pivot even early on. So there's a lot of tools and technology sets available today, working with academics side, that a lot of coming up generations can use. And that had been monumental for us, for our success at least.
Yeah, and I just want to reiterate that I agree. The LUBAR Entrepreneurship Center, having come back for my MBA, that's something we did not have that type of programming when I got my undergrad. And I mean, no offense to the MBA program is great as well, but I honestly think that I learned more through the LUBAR Entrepreneurship Center, through the Startup Challenge, through like-minded people and sharing ideas, specifically to the entrepreneurship space than I did, in the core program. So really, those added resources are a huge benefit right now, and something I do think that we're really leading. The UWM campus is really leading on in southeastern Wisconsin.
No, I completely agree. Like I said, I did the Lubar Entrepreneurship Center's I-Core program as I was doing MBA. So I had two going together. Good thing was they were just across the street, so I could get together. But it definitely added up that extra touch that we needed in this area. So kudos to all that group.
So the next question, so what has been your organization's biggest obstacle in being innovative? So.
Well, for us, I think the biggest challenge has been that not necessarily letting people know about the technology. I think people have heard about laser scanning before, but we have to be very evangelical and very positive about the ability for folks to use this data set. I think that that folks assume that there's highly specialized software that's required, that there's unique challenges that are insurmountable. I will say that right now it is, going back to sometimes more data is not a good thing. Even a modest data set, if you're working with a point cloud, can be 10, 20, 50 plus gigabytes, and so managing that data can be troubling as well. And so how do you really make that something that they understand that there are tools available often within packages that they've already subscribed to. The Autodesk platform has specialized products that work with point clouds, that work with reality capture assets that most people haven't used. And so just making them more comfortable and encouraging them to give it a try, to download it, to play around a little bit. That's something that we continually need to reiterate, is that these are all things that are meant to make your life easier and that they are easily incorporated into your workflow. But that's something that it's although it's simple, it's not as simple as just opening up a design software and going and just going off to the races.
We're a large organization. We're talking 25,000 people, probably 5,000 or 6,000 is technical talent, is engineering. We have something like 16,000 SKUs, an enormous product portfolio. So the challenge we have is our devices last really, really long time. They have to last in the field for, in terrible conditions for a really long time. And our customers expect us to support it even longer, right? Like 30, we're still fixing cathode ray, to devices that people send in. So the challenge of innovating in an ecosystem that has to be backwards compatible, it has to, it's not a consumer device in the sense that we can just stop supporting. So to deploy an SKU or to deploy a product, if one of our customers adopts it, we own it. It's going to be 30 years. It's going to be a long haul for that piece of software. It's not just, we don't do that anymore, right? That doesn't work. If somebody is basing $1 billion asset that this thing is supported, which is not hyperbole. So it's our scale is a huge strength, and a huge strength. I have resources that are trivial, like that would be very, very challenged to get in a small environment. I have a machine shop just down the hall that can make anything I could want. I have the blessing of having tremendous capital assets that I can just have and deploy on research projects as needed. So our scale is absolutely a strength, but our scale can be a challenge. When we deal with startups, sometimes they don't understand why we can't just do it. And I'm like, I have to worry about all these issues when it comes to supporting this thing forever. And so if I'm going to try something, it has to be done in a very controlled environment. I have to have a customer that understands that this isn't a product yet, because there's a huge amount of expectation that comes with that. If you call us, we will fix it. So if that thing is random and we've never, we deployed it twice and have never heard about it, somebody's going to have to fix that. And so I love it. Like I love what we do, and I love that we have that's a great problem that I have a huge customer set and all that. But so I don't know that I'm answering your question like directly, but that is the challenge when I talk to startups and people. What people don't realize when they're dealing with an organization at this scale. Does that make sense?
Yeah. Sort of that there are sort of these structures that are in place because you're a more established organization that kind of put guardrails on, kind of, or limit the canvas, I guess.
Yeah, like we have a policy around design for security. The incredibly high integrity of our devices, because they're cyber physical. People, we're going to do it right. We can't. It's hard to just try it. We do all the time, but we do it in a controlled way.
Yeah.
So I think our problem is probably just the opposite somewhat. Being a startup, you want to try a lot of things, but then being innovative obviously comes with a cost. It's not that you have billions of dollars, like Kyle was mentioning, that you can play around with, even in a controlled environment or not in a controlled environment. I think our biggest challenge is not resource-wise. We've been fortunate enough to find resources. Post-pandemic, obviously, people are willing to move, work remotely, all that. But in terms of being true innovative, I think our biggest challenge is to be able to have some backup from not just angel investors, but also from a little bit more risk-bearing venture capitalists, where they can see innovation does take time, and to be able to support them along the way is what I think we have seen challenge locally, at least. For example, if we talk about different coasts, people throw money all the time to even the dumbest idea you can think of. So that's where I think some of the challenges come us for being local is being able to have some kind of a backup where companies can support that through a capitalist program, through a VC program. So that's where I think our challenge is. There's no question that we can be innovative. It's just how farther you can go along.
All right. Well, that's some great answers. So the next question. So in your mind, what technology or technologies are going to change your industry in the next 5 years? How should organizations kind of position themselves to best take advantage of these technologies?
So what people, the sleeper out there, right? There's a bunch of examples that we could throw out that everybody's heard of. The sleeper technology that I believe is going to have a substantial impact is ultra low cost single pair Ethernet. So driven by the automotive industry, and that pun was definitely intended, driven by the automotive industry, what we're seeing is this proliferation of single pair Ethernet and incredibly cheap PHYs, the actual communications chip. So it's getting to the point where with tin-based T1S for short, you can have a single wire on a bus architecture, and it's cost effective to put your door locks, your window, your turn signal all on one wire, right? It's going to revolutionize the Internet of Things, because things that were previously not IP addressable are going to be IP addressable. It will be cheap enough to put everything on the internet. So this $1 trillion worth of investment in IT style management tools, etc., become feasible for your light switch on the side of the on your wall, and now everything is software defined. The entire machine you can change the operation of the machine through software. It's not a physical wiring anymore. Yeah. So the automotive industry adopting this will drive scale, and it will be cheap enough that I can put it in everything. So we're on the precipice of fundamentally changing machine design. Obviously, batteries and wireless and all these things are going to have an impact. And I mean, no, we're in an AI discussion, so let's bring that to AI. Now, all of these devices, instead of being dumb, right?
Yeah.
Can be addressed. You can put a tiny amount of smarts in it. Are you being vibrated? Are you hot? Are you cold? Are you, name it? Think about the distributed network of stuff that can be enabled, because it's actually cheaper to make it IP addressable than it is to wire it physically. So it's going to be profound.
That's really cool. Yeah.
I think I can go next. So for me, I think the biggest thing that we are seeing changing game is edge computing, like Kyle was talking about. But it's not just the edge AI. Once you add the quantum computing and AI together, I think that's where a lot of research has been going on for a few years. I think it's like a light bulb situation. When this happens, it will revolutionize the industry. With the power of cloud computing today, we are already seeing a lot of advancements that were not possible before. But once you compute it at a power of quantum computing, it's just tremendously increases, and that low-cost model that we were talking about earlier, that starts to drop, and the computation will drive a lot of the AI momentum going forward. So that's where I see a huge potential.
Yeah, I see some potential in AI in our space, but I think that what's unique is that precision is so important that really the interpretation and the extrapolation is something that that may be a little problematic. Nerfs are a way, and let's see, I know I have the definition. Nerfs, that is neural radiance fields, and basically it kind of generates 3D representations instead of really exact 3D copies of what's happening in a space. And that's great for kind of giving a general view of the space. It might be great for video games and that type of thing, which is an area of reality capture that is not something that we focus on, but it is certainly something that could be disrupted by that. But I think that for us, what might be more impactful is the accessibility of the technology, the core technologies we use, and really the continual improvement in that space. You know, what a lot of people don't know is that the newest iPhones have a LiDAR scanner right in the iPhone. I'm not sure if everyone does. I know that I used it as my justification to get the Pro, even though I don't use the LiDAR scanner on it very much. But that is something, you know, that's already being adopted. Now, it also has some great limitations. I mean, instead of a terrestrial laser scanner that can basically capture any data point that is within line of sight, if it is a block down, if your scanner can see it, it will capture it. The LiDAR scanners are much, you know, closer range as far as kind of the dependability goes, and also it's a fixed direction. But I could easily see there being ways, you know, right now an iPhone already has a camera on the front and a camera on the back. All of a sudden you have a LiDAR scanner on the front and on the back. Perhaps you're able to increase that range, and all of a sudden, you know, it's something that might be a little more disruptive. So I think that the adoption will continue to be you know, more widespread. But also, I think that will also, there's also the potential when we talk about, you know, being evangelical. I think that as long as the more robust data collection methods are still on the cutting edge, at the very least, I think what's happening is you're getting that many more people exposure to creating point clouds and to creating these data sets and to really experience what the use case is. So, you know, there's certainly pluses and minuses there, but you know, I would say that just the technology becoming, you know, more and more accessible is certainly something that you know, that will disrupt things.
Fantastic. So, you know, the last question I have here, so we have a bunch of students in the audience today. What would be your advice to those who seek to become innovators? You know, is it, you know, certain skills that you would suggest, or, you know, technical skills or soft skills? You know, what would be your advice?
Emotional intelligence. You can be gifted in your technical field, but if you don't understand how your behavior impacts others, innovation is a contact sport. It requires multiple disciplines. It requires, I have to talk to my lawyers, I have to talk to finance, I have to deal with my employees. Understanding yourself, your strengths and weaknesses, and developing a sense of emotional intelligence will take you very far. I'd rather have a B player that is of high integrity and understands how to be a team player than an A player who is a jerk face, right?
Yeah.
So the number one thing I interview for is emotional intelligence. If you got a degree from a university that I know is accredited and I understand the staff and their teaching, I know you can do the math. I know that the technical side's irrelevant. I can teach that. But if being trapped in an airport with you, I would end up like trying to jump in front of a plane or something. It's not going to work. So that's what I would say. Emotional intelligence.
Yeah, I mean, as a student very recently and someone that's kind of gone on this entrepreneurship journey, I think that emotional intelligence, absolutely, but going along with that, just understanding the importance of interaction, of learning, from your peers, of really listening to your peers, of embracing other people's ideas, of really of not getting too set in the direction that you're looking at necessarily going in. It's something that that you could think your idea is great, but that there might be an easier way to do it. There might be something that's more efficient. It might already be done somewhere and you weren't aware. And so I think that really that's very important. And yeah, I think that what else would be important would be just the ongoing experimentation, get hands-on. What I've found is that most softwares that that you might need, they might be cost prohibitive, but generally there's a trial of some sort. And maybe multiple trials, not encouraging that, but you can get hands-on and you can really start to experience these things. And I think that what's important about that is not necessarily becoming an expert in every one of these areas. I mean, I think that the hybrid nature and the using components and the strengths and compensating for the weaknesses of different technologies is where it's important. But I think that what's helped me is that I've learned enough to be dangerous in a lot of areas, but not enough to certainly not enough to be professional. I don't think I'm proficient in design. I'm not an expert drone pilot. I don't have the wealth of experience that others have with laser scanning, but I think that again, kind of going back to the comments about what's great about the Midwest and about getting that exposure, continuing to really seek out that exposure, that's very important. And I would also say that as an entrepreneur, the importance of your network is something to not to be downplayed. Get on LinkedIn, interact in LinkedIn, continually get new connections. Everybody on the panel here will be getting a LinkedIn invite right after this meeting, because it's very interesting what you guys have brought to the table, but also that network is really going to be key in the future. That's how you make your connections. That's how folks, Scott, that's how you reached out to me. Hey, I just some of the things on, hey, this is the stuff we're doing, and this, it's really neat, and that provided your exposure to this. So, I think that networking virtually is important, but then also, it's something that's a little bit slower to recover post-pandemic. But the importance of industry, industry specific trade associations. That's something that I'm involved in several, and I'm not a young, I feel young, but I'm not as young as I was when I got my undergrad. And I feel like that is something that is still very important, but I don't see enough young faces in the architecture groups, in the construction groups, in the engineering groups, general contractors, that type of thing. And I think that that will be a detriment long-term, but also that's a huge opportunity, that if you really embrace that and embrace that, anybody over, the age of 35 is probably more involved in this, then you're going to get plugged in at a higher level. You're going to build your network faster. You might have leadership opportunities. You might be offered a board position on a local, group or a committee position. So you're building your resume in a really proactive way that isn't just dependent on your employer. So yeah, I think that is very important as well, is just embracing both the new and the old ways of networking.
I'll go next, obviously the last, and I'll save the best for last too.
Yeah, right.
So I think one thing that struck me while I was starting my entrepreneurship journey was finding your why is probably the key to innovation. If you cannot find your why, there's a book out there from Simon Sinek, if anybody wants to read up. But if you can't find your why, the whole innovation will falter apart down the road. You'll start very passionate, you'll have all energy and innovation mindset going on, and you will be conviction wise, you'll be right up at the alley. But if your why does not align with your innovation, I think that's where there's a huge percentage of startups going down. 2/3 of the startups do not even make to their third years, the statistics wise. But once you find your why and you can connect that dots with your innovation, you will find a path forward. How can it be a sustaining innovation versus a disruptive innovation? That's the other thing that plays on a lot of time when you're an innovator. Are you a disruptor versus a sustained innovation? So finding that why, like I said, is a crucial pathway for any innovator starting today. And then along the same line, emotional intelligence right up the alley for me as well. So kudos to, I guess, all three that regards that emotional intelligence does come as an innovator, as a thought leader that you're building your company based on. The other is local. Third point is the local networking connections. Like I said, Lubar Entrepreneurship Center is a great example. And it will even help you to figure out if your innovation is a go versus no go. For us, like I said, we did pivot early on. So seeking that mentorship and advice as you're building your innovation, you could have the greatest idea in mind, but if you haven't done a true customer discovery, that's what helps you understand, can it be something that you're building can be sold in the market and somebody would pay for it. So that's a lot of that mindset, mentorship, connection local did help us when we were starting. And that's, I would suggest the same. There's actually a local UWM incubator program now as well. I don't know if many people are aware of that. But that incubator program we were still part of, we were finishing up this almost at the end of it. That also helped us tremendously connect with local channels and also understand what goes in the mindset of building a true innovation. So those are the 3 points I wanted to highlight.
Fantastic. So those are all my questions. So now we can open it up to the Q&A. If anyone has any questions, feel free to drop those in the Q&A section there.
And as we generate those, I'll also say that, as we just talk about networking, I'm just thinking about kind of my lessons in networking, and really networking becomes more and more important when you're wearing many hats and when you need to identify and create new opportunity. And, one tip would be to go to the thing. I can't tell you how many times almost all of the great new opportunities I feel like I've gone to are at the events that I didn't think I necessarily needed to be at, but I went anyway, and it was great. And also when you get there, don't make assumptions. What I've learned is that the events that have 150 people that you think are going to be great, sometimes they are, but there's meetings you've gone to where, hey, I've signed up for a thing and it's going to be, it's a 3-hour thing, and I get here and there's 6 people here. Oh, great. Well, those 6 people, you develop a better connection with them. You get to understand, their needs more. You get to, really build a strong rapport with them. And so, really that, go to the thing, book your calendar up with fun, networking type things, and go to those little things that are on the fringe. If there's a job fair that you could have a booth at, even though you're not hiring, go, figure it out. Because it might not be, it might be a student that you interact with down the line. It might be another, person that has a booth that you end up interacting with. You might learn something as you wander around, whatever it may be. Just go, get out there as much as possible.
That's fantastic. Yeah. I agree. Going to actual events and meeting people and talking is also where I feel like I've always gotten all of my opportunities as well. So, all right. Well, if any of the folks in the audience do have some questions, I don't see any currently, but if you do have some questions after this is over, feel free to shoot me an email at shanky@uwm.edu, and I can forward that to any of the speakers that we have had for today. And I guess this will conclude our analytics symposium this year. Thank you for attending, and thank you to our sponsor, Church Mutual Insurance, for providing the funding to set up today's events.